بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد عليه الصلاة والتسليم. Good morning, everyone. Welcome you to this very important session as the surface and groundwater. It's very important actually to talk about this kind of topic that is very important for everyone who's working on the water. We don't want actually to give much, a lot of introduction to the session because everybody knows exactly the importance of this topic. Also, welcome the behind the scene from who's joining us virtually. We will be having 5 presentations today. The first one will be given by Dr. Yusri Matar. I'll give a brief introduction to our speaker. Dr. Yusri Matar, he holds a PhD in geology from Suez Canal University, Egypt. He has some kind of academic some experience about geology, surface water, and advanced studies. He has more than 25 years of experience in the water business. He has multiple experience in applied geology of water resources and worked as a technical member of a wide range in Egyptian and in Saudi Arabia. He has published many publications, peer-reviewed journal. The floor is yours, Dr. Yusri, and good luck. Please be on time, 20 minutes for this presentation. And the other presentations will be assigned for 15 minutes only. Thank you.
Thank you, Dr. Mansour, Chairman. Thank you very much. And I would like to welcome all colleagues. This presentation was already submitted from me, Yusri Matar, and my colleague Ahmed Al-Ghamdi, the General Director of General Directorate of Water Resources in Ministry of Environment and Water and Agriculture. The title, Hydrometeorological Study on the Impact of the Weather Condition Rahu on the Water Resources in Southwestern Region, Kingdom of Saudi Arabia. Overview, introduction, aim and objective of study area, methodology, data collection, rainfall statistical analysis, rainfall harvesting, conclusion, and recommendations. Introduction, as we know, all the GCC and the Arab countries had a climate of arid zone. In arid zone, as we know, and our colleagues already before talked, this arid zone exhibits strong, especially variability and sporadic rainfall. The rainfall is very most important element in preparing of water budgets and surface water allocates for various water demands. Flood events in arid zone, as we know, some heavy rainstorm may be prevailed in the arid region, happened annually and continuing for a few days or many days, resulting in extreme flood events. As we show these figures, many heavy rainstorm prevailed in Saudi Arabia at Jeddah, November 2009, Rumah, Riyadh, November 2016, and Tabuk 2013. In 1953, United States began to using short name, distinctive names for this storm to characterize this storm and prevent any confusion from multi-rainstorm. And they give female names for the storm and then female and the male, and finally adopted in 2079. Very, very important, in January 2011, the Saudi Committee for Nomenclature of Distinctive Climate States has been established. This is a non-governmental committee, has been established to achieve many goals. Among of these, giving a significant name for the distinctive climate conditions, facilitate follow-up of this climate weather, carry out the hydrometeorological study, prevent any confusion with another weather condition that may be occurred in the same time or in the same year. Some distinctive weather conditions prevail and have distinctive names by Saudi Committee for Nomenclature as مغدقة. مغدقة lasted for 31 days, 2011, and البيضاء 14 days, سابغة, الرباب, and we will remember الرباب for more discussion, جود, and غدق, which lasted 27 days from 2018, and Rahu. This is our study now. About 30 distinctive weather conditions have prevailed in the interval from 2011 to 2020. Aim of study, why the present is needed. In my opinion, that this is the first study of this type, of this object, to study in details the impact of like this weather condition on the water resources of Saudi Arabia, even water resources, surface water or groundwater resources. From the beginning of this rainstorm in 24 July in 2020, we already recorded and noted critically for 18 days. It lasted up to 10 August. The aim of the present study is understanding the rainfall pattern during the weather condition and also investigate hydrometeorological impact of the weather condition Rahu, in Arabic Rahu, on the water resources in southwestern region, then estimate the rainfall harvesting. This is a very important tool. This is a conclusion. What is the rainfall in harvesting, surface runoff and the recharge on the impact of this rainstorm on the water resources. This is very, very important in the design of flood mitigations and also characterize the allocates for various demands on the treatment plants constructed on the dams. And finally, manage and optimize the benefits from this renewable surface water and update the operational plans of dams in Saudi Arabia. Methodology, as we know, this is the spatial distribution, then calculating the affected area, calculate the affected area within each region. 6 regions affected with Rahu, 6 regions, Makkah, Asir, El-Baha, Jazan, Najran. We also calculate the affected area with Rahu. And finally, we follow the daily and the monthly rainfall records on the corresponding interval in the last 10 years or the fall record. Data collection, the main data using in this study is from MIWA hydrologic network. MIWA has installed very strong hydrological network consisting of more than 1,000 stations, rainfall station, runoff station, weather station, and monitoring wells. In my opinion, this is the strongest hydrometeorological network in the GCC. Also, some of these stations have a long, relatively long record, like FIFA station, which is extending from 1953 up to date, more than 65 years as a record. Data collection, this is the distribution of the hydrometeorological network in all regions of Saudi Arabia. This is a figure to show the geographical distribution. This network is highly geographically distributed, and multi of these stations give a real-time reading and give a good idea. In this study, we use the record of 573 stations, but not all these 573 stations are already record. Among of these, 193 stations only record rainfall during Rahu weather condition. This is figures for the weather station and so on. Rainfall statistical analysis. As we said, that the only 193 stations used or recorded rainfall station events in this rainstorm Rahu, already using spatial analysis by ArcGIS tools, or isohetal contour map already created for each region. This is a table on the left hand, 193 distributed and covered most of 13 regions of Saudi Arabia. The total 573. 103 is the average annual rainfall for the total record of these stations. This is a real-time weather station automatically sent to the MIWA website. Also, we obtained during the weather state Rahu the rainfall precipitation from radar from NASA to confirm the reading recorded by the rainfall station. This is an isohetal map for the Mecca region during Rahu. As we know that only 53 stations recorded during Rahu from the total hydrometeorological station within the Mecca 108. The total affected area, geographically affected area from Mecca region, only 63% from the total area of the Mecca region. All the another 6 region already, Al-Madina, Asir region, Al-Baha region, Jazan, and the Nagra. Results. In the time? Okay. Result, affected area, the total percentage of the affected area by Rahu, only 11% from the total area of the kingdom. This is very, very important to know. The total 11 only, but the total affected area from the total area of 6 regions attain 40%, but from the total area of kingdom 11% only. As we know, distributed, geographical distributed, and the percentage of the total area recorded in Rahu. Precipitation and runoff. Also, this is a very good criteria. How you can estimate the rainfall volume, how you can estimate the runoff volume. As we know, the summary, the summation of the total average precipitation volume during Rahu during 18 days attain 10 billion cubic meter. What is the volume from this rainfall precipitation? The corresponding volume of runoff station attain 1.3 billion. All the hydrologists can calculate simply or empirically what is the runoff coefficient from this. We can divide it, the runoff volume by the rainfall station, the precipitation volume, give you the runoff coefficient during Rahu, and this can be considered as a criteria or empirical formula in the further study. This is also the maximum daily precipitation, day by day record, or our collegios recorded critically. As we know, the maximum daily precipitation received in one day in one station, Damad Dam station in Jazan, attain 83 millimeter in one day, maybe in 2 hours only. Also, average monthly precipitation. This is a very useful figure. As we know, highlight on July. July month is considered a dry month in generally in all kingdom. But July during Rahu 2020 received in this month attain 28 milli. But the general or the average precipitation in July attain 3. This is a very useful. That's meaning we can receive the total precipitation in 80 days or in one rainy storm. This is very useful to study the rainstorm like this. Also, the August, the average total precipitation in August 9 millimeter, but in Rahu it attained 12.7 millimeter. This is a correlation between July during Rahu and August during Rahu with July and August from the last 10 years. We can achieve that the July in Rahu, 20.8 the average precipitation, corresponding with the 14 millimeter precipitation during only the last 10 years. Runoff harvesting, this is the main conclusion. What is we can obtain the runoff harvesting? This table is very useful. The storage capacity behind the dam before Rahu, 596. After Rahu, 738. The net storage, 142. During Rahu, we released the gates of 43 dams to discharge, flowing the water in the wadi to rising the water level of the ground, the groundwater and the farmers' wells. This is very useful for agriculture and irrigation. Also during Rahu, we use about 8 million in the water supply in the treatment plants constructed on the dam. The final volume received on the dam attained 352. Someone can ask, what is the percentage of the obtained received volume in the dam correlated with the total runoff? I think that the 30% from the total runoff can be received in the dam reservoir. This is distributed on the all region. Also estimated average runoff coefficient on the region can be obtained. Among these 43 dams full and spilled. This is very useful criteria. But the total number of dams affected by Rahu, 147. 147 dams affected by Rahu from the total constructed and under constructed dams in Saudi Arabia attained 574. The emergency operational plan applied. We will go to the final conclusion. The total flood of volume in Najran only, we received 112 million cubic meter in Najran surface dam, followed by Jazan in Bish and Jazan dam. The total volume released from the total dams, this is distributed on the total area. Frequency aura. In the other opinion, that the Rahu can be considered as a frequency of a Rabab. A Rabab is the summer rainstorm from 2016. It is frequency. The frequency is the Rahu 2020. That meaning maybe will receive each 4 years as this like rainstorm.
You will have 2 minutes.
Yeah, fine.
Try to finish up.
Conclusion. As we said all this, and we will reach the recommendations to accommodate with the time. It is advised to use the Rahu rainstorm as a guideline for the design of flood mitigation and the dams. This is good criteria for you. We select the design storm in the dam. Also, the present study recommended the develop and update operational plans of the dams and the continuous coordination with the civil defense and the Emirates for the region, highly recommended in to warn the citizen to be out of the Wadi stream. A free storage volume must be maintained in the dam to be as a free storage to receive more runoff during any next step. This is the final. Thank you very much. This is the time. I will acknowledge His Excellency Dr. Shabani, the Deputy Minister of Water, for his encouragement and his support. Also acknowledge my colleagues, Engineering Sulaiman al-Shanan, Engineering Said Daer, and all our colleagues in Surface Water, Engineering Ahmed Al-Ghamdi, Engineering Mit'ab Al-Qahtani, and all you. Thank you very much. I will to achieve the goal of the time. Thank you.
Thank you very much, Dr. Yusri, and I think that you finished on time. There was a challenge, as I heard, between you guys, and you won the challenge. So we have when we have only one question, please.
After the whole.
Please, we will be having just only one question. But if you think that it's important to be asked, ask.
Thank you for your presentation. Really, I'd like to ask you about, you mentioned we have good record for the flow data within the criminal. Would you please explain us what is this data and how can we get it? Is it accessible? And because when we asked him before about this data, he said, no, we have very rare data and even so old. And even this hard copy, digital, is few. And so please tell us.
Thank you very much for this. All the available data already available on the website of MIWA, and they're already under updating and upgrading to be free for all the users and for all the scientific for this. In the next few days or few months, you can obtain with the submitted official letter for His Excellency the General Directorate of Water Resources in MIWA, and you can obtain on hard disk. This is only for you, not for others.
This because I know because I associate website.
Yeah, okay.
So I do some organization for this project and master PhD. So when some students came to me and asked about this data, they told me, okay, they need a data, and okay, we write the data and we send it to the ministry several times, and the end they tell us, we have no data, especially for the true data.
MIWA already prepared for all the
suffering.
Not more keep it on the desk. No.
So how can we get it?
After meetings, you can submitting official letter and send. I will follow up with our colleagues and this.
I know that's some kind of confidential information that MIWA has because I'm working for MIWA.
I'm working for me. I know some information that shouldn't be released, but they think they're under those information under verification and quality control and some other things. They want to actually release some information that's very confident and they're sure about it. So they didn't want it actually to, but they have a lot of data as far as I know. As far as I know, but yeah, of course, you're not going to get the whole record, though, but at least they will have it. You can discuss this later on with Dr. Yusri. Thank you very much, Dr. Yusri. Wish you the best of luck. Dr. Muhammad Suarez is going to introduce that one day.
Thank you, Dr. Mansour. The second presentation is on hydroecological techniques to improve the infiltration of clock bed recharge dam for the for Dr. Ali Al-Qudami. Let me give a brief introduction to Dr. Ali. Ali Toumi works at the Water Research Center and College of Agriculture and Marine Science, Sultan Qaboos University, Oman. He is an associated professor in water resources management and director of Water Research Center at Sultan Qaboos University. He has obtained his PhD in environmental engineering from University of Queensland, Australia, in June 2007. So the floor is yours, Dr. Good luck. And also, you know that time limit is for 15 minutes, 5 minutes for lecture, and 3 minutes for discussion.
Thank you very much, Mohammed, and welcome you all to this presentation. And without further introduction, my presentation is, I already presented part of this in a symposium invited by the Ministry of Environment, Water and Agriculture in Saudi Arabia. And the talk is about a potential hydroecological solution to enhance infiltration and recharge in clogged recharge dams in arid areas. So I have to go next by this. sorry. Okay, I'll skip the overview. So let me give you an overview of the situation of dams in Oman with all the three types. We have recharge dams and surface storage dams, small scale, and we have the major or a big one so far, Wadi Dhiqa Dam, and a number of protection dams. In total, this makes 174 dams compared to several hundreds in Saudi Arabia, as I heard in the opening of this conference by His Excellency, and this total capacity of 423 million cubic meter. In fact, as all of you know in this room, it seems to be a lot of experts in recharge dams here. We know already the impact of recharge dams and the importance of recharge dams in augmenting water resources. And the impact has been proven through a lot of scientific studies, and that through control of seawater intrusion in developed coastal aquifers, and also augmenting underlying aquifers, especially where groundwater is controlled as well. And we have been observed also it contributes, but not to the level we wish in mitigating flood hazards. You will see across my slide there are some references, and this is just to help later on. This I guess would be available. So if you need more details about particular aspect, these are our publications. However, along with the impact of recharge dams, those recharge dams are facing challenges, and one of the major challenges, as already has been mentioned in many presentations in the past, is the sedimentations, which is brought on with the flash floods as suspended materials, and those impact represented by or through degradation of the storage capacity, the design at the beginning. For example, giving here, the dam I will show today is reduced by 33%, and this is causing overflow usually without giving the time for the brought-in sediments to settle in the dam, so transported to the recharge basin, which in fact affects the functionality of the dams later on, which is the recharge to the underlying aquifers. Clogging of the dam's topmost soil and clogging of the toe drains of the embankment, especially for the earth-filled dam. This is another challenge which I will show later on. And those carried on through the spillover of flow sediments, they find their way into percolating vertically into the vadal zone, which alters its hydrological properties. And we have been proven it's more than 10 times reduction by the vertical translocation, which has been trapped at certain depth in the recharge basin, and forming a thin or a fine texture layer, which impedes further percolation of water and causing a quasi-horizontal flow in the downstream area, which is also reducing the efficiency of dam in terms of recharge. Some of these also fine particles, as we'll see in another slides, find their way into the embankments of the dam, facing the lake, which is also these fine materials are having a high water holding capacity. Along with those incoming flash floods, also some seeds comes in from the upper part of the catchments, which with time germinates and grow into these buckets of soil trapped in between the embankments, and that affects the safety of the dam itself. So here I am just presenting two things and highlighting this point just to avoid confusion, because I am promoting the idea of enhancing infiltration in the dam by using the roots of the plants. But when these plants are close to the embankments, they are very dangerous to the dam and should be uprooted. Okay, so the motivation here, again, sedimentation is a problem and we have to find some solutions. And always, we found that always we go for a high-tech solutions, which is expensive or becomes invisible, in fact. And we thought, let's try to see and quantify how much indigenous trees could contribute in enhancing infiltration into the dams. Why inside the dams? It's never been meant to recharge to happen inside the dam lake, but because of urbanization that takes place and shrinking, in fact, the recharge basin due to urbanization, the remaining space for infiltration on the recharge basin becomes limited. So we thought it's a good idea to enhance infiltration inside the lake of the dam to reduce the overflow, which is witnessed frequently now, and also to enhance the recharge because of what I have said now. When the water released down to the dam is just canalized quickly to the sea, which is also artificially reducing the recharge to the aquifer. And we choose the cedar tree, as you can see here. We gaff trees and cedar trees found there are indigenous trees. And there are some studies using sap flow meter in UAE that quantify how much these plants are consuming of water, because people said, okay, you will enhance by 10%, but also these plants will consume water. So how much is cedar tree, mature cedar tree is in fact consuming is around 10 to 12 cubic meter a year, which has been measured by sap flow meter in UAE, and we are also measuring it now, and the results are comparable. The gaff trees up to 18 cubic meter. Okay, so the root system here, this is the motivation. So the root system, as you can see here, those are some pictures just from the dam itself, from some of the trenches excavated in the dam. You can see how strong are those root systems in providing a secondary porosity and an extra passage for water to flow and enhance infiltration, because it's not practical, in fact, to excavate and bulldoze all of those sediments. It's expensive, and the government, the concerned utility in Oman, they are trying this, and but unfortunately the brought-in sediments is too much, but unfortunately we don't have a record of how much sediments is brought into these reservoirs. This is what I have said in the previous slide, so I will not go in detail. This is a very recent study, and this is the vegetation, which is unwanted, in fact. This is 4 weeks old photo, and those are the unwanted vegetation which I mentioned, and it must be uprooted, because when the root system develops into an air-filled dams, the root system always follow the advancing wetting front, and that will increase with time the permeability of the core, which threatens the dam, and it might even in some cases lead to collapse of the dam. And the government, in fact, they are having a program of uprooting this frequently. So the design experiment here, we started with tanks to start to quantify how much each cedar tree, for example, will enhance the infiltration. And later on, we have to move to the field. But this is the first phase of the project, and this is the design. Schematic drawing. The tank is, the dimensions is 90 centimeter, and we backed all of these soils. We put gravel layer to allow drainage if that happens, and also we equip them with sensors, soil moisture sensors, to try to pick up the wetting front after each flooding events. We grow the cedar trees, you can see them here, and we have also 2 control tanks. We equip them with an infiltrometer rings, so we can mimic the flooding events over the 2 years, which is the duration of the experiment, to start to see how the infiltration will improve as the root system develop. But we wanted also, this is some of the details of the experiment, also they are in the paper, so I will just skip these parameters as not necessarily for understanding the results. But also we replicated the big tanks into small booths, and the idea here is also we'd like to repeat the same experiment in order to try to study the root topology as well. In terms of after certain time, we do the infiltration test in these also small boats, but also we repeat the measurements, and also we sacrifice one of the boats or 2 to see the root system, the topology, and also we measure them into length and other growth parameters. The results of the main experiment over the 2 years of repeated flooding events, and we usually mix also the water for the experiment. We mix it with the same sediments in the dam to represent the flash floods and brought-in sediments, trying to be as much as possible representing the reality. So the results show an increase of 6 times the infiltration by the end of the experiments in the tanks equipped with cedar trees. And those are the sensors results, which also showing how it's picked up over, after each flooding events. We have done some numerical modeling also to see the distribution of the moisture, soil moisture into the vadose zone, resembling with the effect of the root, resembling the cedar trees. And this is the hydrous simulation, and this is the initial condition where there is no effect of root system. And then here we run the simulation with the 3 different supply rate of water or supply patterns of water, and in all cases we see the effect of the distribution of the moisture in the vadose zone under the effect of moisture of the root system as compared to this one here. And also we calculated the root water uptake, which is very evident that the water infiltration is in fact increased by more than 6 times. In conclusion, the study demonstrates the possibility of this hydro-eco-engineering techniques for improving the infiltration rate in the dams by almost more than 6 times for these tank experiments. Moreover, intensified infiltration from the dam's lake contributes to decrease of the flash floods of the downstream area, which is also a target. In fact, some people will say, okay, this is a controlled experimental tank, but this is the idea of to understand the dynamics of water in small scale. And then now the team is working in a field experiments where we are creating trenches in the dam itself, in the vicinity of cedar trees, and we equip these cedar trees with saphlometers. We calculate also the canopy to calculate the evapotranspiration and to have the water budget for the whole system is there. And that's why it will help us to have an optimum design for the better management of aquifers and dams in urban areas. At the end, I'd like to acknowledge the contribution of the team who contributed to this work and still contributing, especially our postgraduate students. And the support goes to SQ for the financial support through a number of research grants. With that, thank you very much.
Thank you, Dr. Ali, for a very excellent presentation. And we have a good chance for one question only, and also for exact time. Somebody have a question?
السلام عليكم صباح الخير جميعا.
عليكم السلام.
صراحة شكرا جزيلا. It's for the new approach and it's a good approach for the recharge and the use of the dam. I just have a small question. Have you checked the effect of these trees on the quality of the water?
Simply no. Yeah, thank you.
So now I have any question? Okay. Thank you very much,
Thank you.
Dr. Ali. And the third picture is experimental title or experimental numerical modeling of constructed channel in the desert sand dunes for MAR application for Dr. Afrah. Dr. Afrah is a PhD candidate at Sultan Qaboos University. She did study on dune hydrology by carrying out field and laboratory studies of evaporation, infiltration, heat, and solute transport in the interior and coastal dunes of Oman. So, welcome. Online.
السلام عليكم ورحمة الله. هل الصوت واضح؟
Okay, واضح.
I cannot share my screen. Maybe someone is now sharing his or her screen.
تقدري تعملين دكتورة شير من عندك.
Yeah. Now I'm clicking on share screen, but there is a message. They said you cannot start screen share while other participant is sharing.
Okay. Can now share screen, please?
Okay, wait a second. Oh yeah.
Okay, Doctor.
Is it clear now?
Yes.
Okay, great.
Now we have 15 minutes for introduction and 3 minutes for discussion, please.
Okay, thank you.
Thank you very much.
السلام عليكم. صباح الخير. I'm Afrah Shakeli, a PhD student at Sultan Qaboos University. And today I will give you a presentation about the experimental and numerical modeling of constructed channels in the desert sand dunes for mal application. Maybe here I will start with just a very small question. Can a desert turn into a forest? Actually, turning a desert into a forest sounds like a dream project. But if possible, it will solve many of the environmental problems. For example, we can reduce the erosion, reduce the desertification. Also, we can stabilize the topsoils. Not only that, also it will help to reduce the temperature and also the sandstorms. And actually, currently, there are many projects for greening the deserts, and now almost about 30 million kilometer cubic of lands was performed for the projects of greening the deserts. And there are many and several methods used for worldwide for greening the deserts. And today I will just focus on one methodology. Let's go quickly for the outline of my presentation. It will be divided I will start with introduction, then I will introduce the conceptual model, and then the methodology of our study. It will be divided into 3 parts: field experiments, numerical modeling, and also coupling surface and subsurface flow. Then we will go to the results, conclusion, recommendation, and at the end, the other applications of our model. Okay, so in recent years, isolated communities and also villages in desert area have developed alongside the tourist and also oil camps that are constructed in the dune fields. And there are the interior dunal area can be explored and tested for managing aquifer recharge if natural wadis or small constructed channels can be used to discharge the treated wastewater. And as you can see here, we can construct a small size channels in the sand dunes and then use the treated wastewater, because we have an excess amount of treated wastewater, and almost in the winter about 80% was going to throw into the sea. So why not to utilize this treated wastewater and use it to enhance the groundwater recharge and also making a wetting spots or high moisture content inside the vadose zone of the dunal area by constructing only small size channels. Now the key design questions for our design: what should be the length of the channel to infiltrate all the discharged water from the inlet? If we have the certain topographical slope, if we know the roughness of the channel bed and hydraulic conductivity of also the sand, and specific and how much the amount of treated wastewater that we want to infiltrate in the dunes. So now about the methodology of our study, we started with a field experiment, a small scale, and then we model it numerically by hydrostudy, and then we coupled the surface and subsurface flow. Sorry. So for the conceptual model, as you can see here, for part A, it is a 3D sketch of surface flow we're supposed to use a triangular channel. And here for part B, this is like a conceptual model for a free jet of surface flow in a cross-section along the channel or trench. And here you can see the seepage flow in a vertical cross-section perpendicular to the channel axis. So this is the conceptual model. And then the field experiments. We started with a small scale field experiment. We conducted at SKU. We chose a mini dune made of fine sand characterized by KSAT about 0.91 centimeter per minute. We measured this saturated hydraulic conductivity in the lab by using Darcy apparatus. What we started with a mild slope about 5 degrees, and we selected a constant flow rate discharging of the water about 0.18 meter cubic per hour. We discharged the water on the dunes and we wait for about 2 hours, but unfortunately at the beginning the sand strongly eroded and causing like a winding trench or channel rather than a triangular channel. So how to solve it? We came up with an idea to make a frame with a nylon mesh, if you can see here, with a width about 25 centimeter and the length of this frame about 2 meters to prevent to stabilize the channel to be like a triangular and also prevent the erosion of sands. Then we put it in the sand dunes. We adjusted very well and we make sure that it was in a good contact with the sands. And then again, we discharged the same amount of water. We place it and we wait for about also 2 hours till the water level in the channel stabilized. Then we calculated how much the water level, how water level in the channel after stabilization, and also what is the length of the water jet. Then we used these results for a numerical model. We used recharge equations by using Hydros 2D software. And this is our model. As you can see here, we choose, this is like a cross section. The inlet of the cross section, this is the BDC. This is our channel. The constructed channel, and the domain was about 50 centimeter in length and 25 centimeter width. And we chose the porous domain for the model, sandy soils as in the field experiment, and the saturated hydraulic conductivity about 0.91 centimeter per minute. Also, the boundary conditions of our model here for BDC, for our channel, we used a hydrostatic head, free drainage at the bottom, and impermeable boundary conditions for other sites. Then, after the model become at a steady state, after about 30 minutes of simulations, we choose the bottom segment here to calculate and determine the infiltration rate at steady state condition. And in the next slide, this table shows the infiltration rates that are computed by Hydros for different water levels, height in the trench. We used, for example, we started with 2.5 centimeter at the inlet till 0.5 centimeter at the end of the water jet. And we calculated the infiltration rates. Then we use these values to get the interpolation function and interpolation polynomial by using Mathematica, and we got this equation. I will not go through the details of it, but also we used this equation and we calculated the dimensionless depth of the jets and the function by using Mathematica. Then we solve it and we got the graph as shown here for different, if we have different scenarios or different saturated hydraulic conductivity. Now, to summarize, that the rural areas in arid regions, specifically in the sandy dunes, are expanding and require sustainable and independent water supply for their desert agriculture and also for domestic water use. So our model or our work will help to design like a marked channels.
2 minutes left, please.
Okay, I'm almost finishing. So our model will help to design the marked channels or to enhance the groundwater recharge and also to create wet spot. Also, the length of the propagation of the pre-jet downslope from the inlet is evaluated by this model, and provided a given quantity of water is released into a triangular soil channel. And also, we solved the optimal shape design problems by selection of the seepage losses and channel cross-section area. So now at the end, these channels, if we use, because here I just presented the triangular channel, but also we did the same models for if we have rectangular channels. So these channels can not only recharge the aquifer beneath the dunes, but also to enhance the amount of moisture content underneath and the vadose zone, and then it can be intercepted by the shrubs and vegetation, and we can greening the deserts easily with less cost and minimum time. Other applications for our model, not only for greening the deserts and constructed trench, also it can be used, this work can be used in planning furrow irrigation in the dunes and for crop production. Also, it can be used to apply it for flash floods hydrology, because as you know that the wadis or streams like a big rectangular channels. So specifically, when we measured and evaluated the transmission losses by coupling surface and subsurface flow to predict flash floods waves and avoid great damages to urban areas. Here, at the end, I would like to thank my supervisor, Prof. Anwar Kazimov, and also PhD committee members, Dr. Ali Al-Maktoumi and Prof. Uthman Abdullah. This research was a part of SQ-funded project. Here you can find the other 2 key references that was published by our team. Thank you all, and I will be blessed to answer your questions.
Thank you, Dr. Afrah, for the nice presentation at exact time. And we have opened the floor for one question only. Somebody.
Thank you very much, Dr. Afrah, for this valuable and informative presentation. I have a simple question. This new concept is very, very useful from hydrological and from hydraulics point of view. But my question, in sandy dunes, how we can design like channels to serve different settlement and maybe causes the destruction of this construction. From geotechnical point of view, we can design in safe manner this channel, because the sandy dunes already move, maybe month by month, per year, but per year, maybe you design this channel this year, completely remove them the next. How we can say design for this recharge channel? Thank you.
Thank you. Some parts of the question I didn't understand. The voice was not very clear. But do you mean how we can solve the problems of the designing the channels from the erosion, or?
Channel sides and channel bottoms, how we can save the design from geotechnical point of view?
Yeah.
Can you hear?
The voice is not very clear, but maybe.
From geotechnical, please make the question precise and short, because she was lost.
From geotechnical point of view, how we can save design of these channels against the destruction due to the movement of the sandy dune.
Yeah, very, very good question. Actually, in this, as you can see that I presented that for the small scale experiments, we face the same problem, geotechnical problems, that the sand eroded and we cannot stabilize the channel. But for larger scales, we can use the same thing. We can use this nylon mesh frames and put it on the sand dunes, but it will be in larger size. Actually, it needs to maintain it from time to time. But this is like just a proposal. Also, we can use only just discharging this treated wastewater directly in the dunes, and it will make, like, as you can see in this slide, it will be like these winding channels, and it will stabilize by the time. So still, because this is only like numerical and analytical models, and if we want to design it, actually we want to think about all the geotechnical problems. Thank you for your question.
Thank you, Dr. Farah, for valuable and informative information and for good study. Hope for you. Good luck, and thank you very much. I give my floor to Dr. Mansour, my colleague, Dr. Mansour, to introduce the fourth lecture.
Shukran, Dr. Muhammad. Thank you very much, Dr. Muhammad. When I'm sitting here over here, I actually seen a lot of scientists and participants to this session. It means that is very important. I think that it triggers my mind right now how to make another one actually a new one, and together all those are distinguished guests from different entities. So expect in the nearest future that could be something coming. Thank you very much for coming to this work, to this session. Our next speaker, he can think, oh, this is why I'm wearing sunglasses.
I have a second.
Thank you. Thank you. Our next speaker, Dr. Al-Zubari, is he among us today? Aha, you are the shiny gun. Dr. Al-Zubari is currently Associate Professor of Water Resources Engineering at King Saud University, and he earned his bachelor degree in civil engineering from Ain University, master's degree from National University of Ireland, a PhD in civil engineering from University of Riyadh, Germany, 2002. He has published more than 25 original papers, conducted more than 20 conferences. His title, Flood Damage Assessment of Vulnerable Area in Riyadh City, Saudi Arabia, case study at Mama Bridge. The floor is yours, and good luck, Dr. Ibrahim, and please be on time.
Okay, thank you. Thank you. Okay, thank you, Doctor. Assalamu alaikum. Actually, flood, and all of us, if we hear about this flood, we think that we have really flood. But just, I'd like to just clarify something. In arid regions like what we are now, we have or we receive little rainfall. If we distribute this amount of rainfall throughout the year, we'll have nothing. But we'll focus, the point that we'll focus only on the rainfall which will happen during a short time. This is the reason that we supposed to be having this as like flash flood. So flash flood potential, it is very important to consider it because it caused a lot of problems during the storm event. So
we look for this event to determine how much or how frequency this event occurring, and what is the factors affecting this, and what is the potential for this value to consider it to have like measures or like flood measures for this phenomenon. Actually, the topic here just to focus on flash flood potential and selected like a vulnerable area in Riyadh city and take a case study for Thumama Bridge. Actually, this we can summarize this talk to some very little introduction and the study area which I focus about it, then the methodology, brief for the methodology, and some results, then the conclusion and some recommendations. In fact, floods or flash floods causes losses, which includes loss of life, soil erosion, damages of properties, and environmental damages. Saudi Arabia is one of the countries that are prone to the risk of floods that cause different types of damages, especially different through the last 2 decades. The highest past flood events, and maybe the worst flood in the area in 50 years, and their damages in northern western region of Saudi Arabia were in the 24th of December 1985. Estimates of damages were not recorded, except at least 32 people were killed or died from this flood. In January 1997, mainly affected Yambo and the areas of Jeddah, especially Jeddah. It was also noticed in the rain lasted for 24 hours, where 10 people were killed, and an area over 130,000 kilometers of land was damaged. Other area like Asir and maybe for also western part of country, especially in Jeddah, and all of us we heard about in Jeddah, and also what has happened in Riyadh also during the last decade. In Jeddah, November 2009 and January 2011, different areas have been affected. 216 heavy rain for storm lasted for more than 12 hours on the dome located in south of Al-Kharg town. Actually, the flood damages happened in Thumama Bridge, this is in Riyadh, were due to one of the heaviest storms that hit Riyadh city in November 2013. The storm in Riyadh caused an evacuation of people in danger and soon sheltering them. Riyadh city is considered one of the cities are vulnerable to flood risks in Saudi Arabia due to urbanization and risk development as well as climate change. Actually, this photo, we found it through the net, and we like a scale or small scale for one of the bridges, which was a failure part in Thumama Bridge, which happened during that storm event. Actually, this one of the flash flood damages, which we may get it, especially if this rainfall happened in very short time. The study area, Thumama Bridge, is one of the bridges located at the Wadi Banban passway in Riyadh. The bridge this was vulnerable to flood damages in 2013 and led to bridge failure, as we see as a part of bridge was damaged. 2 piers was completely damaged. And the bridge was consistent of 13 openings with a total length about 195 meters. The catchment area of this Banban about 381 kilometers square. We'll see here, this is the location of the bridge, okay, and this is the wadi. Before, of course, if we'd like to study this, the effect or how much is this flash flood potential, we start to have like a conceptual modeling. Conceptual modeling, this consists of hydrological and hydraulic modeling. So at the beginning, we should have data collection or a good record of the data. This may be where I asked about what is the reliability of this data. And one of the main input of this data or this conceptual modeling is the rainfall. So we have to collect reliable data to have or to get reliable also results or to simulate what is going for this catchment. For this data, we consider or we look for the short-term data. Yani not only on the daily basis, but supposed to be we have also on the short basis to have a frequency analysis of the precipitation data, because this is the main input to the model. If we have less or have long record, but we have much missing data, so we'll have of course, not reliable data. So at the beginning, or before we go to the methodology, if we brief this methodology, our first step to have meteorological analysis. Meteorological analysis, actually at the beginning, it's better to update what we call it IDF curve. IDF curve, this relation between the intensity of the rainfall and the duration and the frequency. To have this a formula or this is a curve, because it's the main input to the hydrological model. To have this, actually, we collect good record for different stations. Of course, if we focus on this the area, because this 381 kilometers, and the number of stations, of course, not enough to present this area, but at least we can manage with the available data. But it's important to have a long record, at least 30, 40 years historical data to improve or to get updated IDF curve. Because it's important. If we update, and actually this is not only in this area, it's supposed to do it for all the areas in the kingdom or other countries. Because if we have this, of course, the next step, it will be easier, or the other data we can, of course, collect it in a good manner. To have this curve, actually some frequency analysis we tried for like Gamble, log Pearson, log normal, gamma, and etc. And to get a fit or the best fit to fit the data based on some criteria like chi-square test, like root mean square error, and others. To have these curves or to have these equations, then we have, of course, to determine the boundary of the basin itself. The boundary of the basin. Boundary and all the morphological parameters, because this is also important. What is also good data for this? A digital elevation. So we have determined the basin or the drainage basin, the catchment, and the morphological data. Watershed modeling system is a good modeling for this, used to determine the drainage basin and the boundaries of the drainage basin, pathway, or the flow path connectivity, the stream networking, till we get as like a branch streams for the catchment area. Actually, hydrological modeling is very important to have all this data. Then we use hydrological HMS. This is a series of the HMS, or like HIC HMS, and also we move to hydraulic modeling. Before we move to hydraulic modeling, it also good parameter is very important with which technique you are using to determine the peak flow at the outlet or different subbasins. One of the techniques is we call it a curve, or what is the curve number, or soil surface curve number. Actually, to get a curve number also, we need good data. This regarding to this land use, soil type, okay, and some hydrological soil groups. To have this data, of course, and we got estimate for this curve number, but like a weighted, because this is varying based on the parameters which I mentioned. So on, we get this weighted curve number to be about 81 according to the land use and hydrological soil group. This one also output to get the curve number and the boundary of catchment. As we see, like part of the area is a desert, and also the other one, about 50% desert area. The other desert, but it is rocky, and very little percent, about 10 or 12%, it is urban. So hydrological analysis is conducted to define the hydrological parameters for the main wadis, contributing with the study area and the time concentration, lag time, as well as peak discharge resulting from the catchment areas. This done is by HMS, or Hydrological Modeling System, HMS, the methodology of SCF or curve number method. Hydraulic analysis and HECRAS computation, just to determine or for hydraulic characteristics, such as water depth, water velocity, water levels in front of and behind the bridge, in addition to the dimensions of the water section at a specific location, as well as scour depths. And this will look for about it. What is the cause of this damage? Definitions of reaches and the geometry of floodplains and demanding roughness values are required also by the hydraulic models. This is the reason also we should have at least few records of flow data to calibrate these models, to have some calibration and then verify the model to get a good parameters, or to estimate the parameters. But we do some trial and error to achieve the goal. The extraction of channel, center line, and the floodplain.
You have 2 minutes, sir.
2 minutes? Okay, okay. Just almost. Go to the results. The prediction of rainfall depths for we just select 50 years and 100 years as a return period as a frequency. We're estimated to be about 47 and 50 something millimeter. The methodology of the curve number was performed to estimate the peak flows at the catchment outlet point to be about 270 or 290 for 50 and 100. Almost we focus on 100 years to be out to design. Then the weighted curve number estimated to be 81. في hydraulic modeling, the manning roughness coefficient N was increased to be about 0.30 to dissipate the energy at the baffles or the drops. The scour was estimated assuming in the valley cross-section doesn't tolerate the high water velocity, and scour depth was estimated using HECRAS, and the results was shown about for 100 years, about 5.7 meter at the pier 1 and 5.6, almost the same for the pier 2. So the good depths. And on the other hand, the water velocity was estimated to be 6.3, this constraint, where it is somewhat high. So we may add more baffles to reach the allowable water velocities. Another alternative solution to be proposed by altering also, or to maybe change, or we may have another scenario to change the cross-section of the valley at the upstream and downstream of the bridge to make sure that there is no hydraulic interference between the water section and the pier location, as well as avoiding the high water velocities. This one of the output of the HECRAS model to show us what is the water surface profile, and also we're interfering with the piers here under the bridge. In addition, some people also, we can focus on what is the flood inundation area in other areas, in addition to the piers at the bridge. The conclusion and recommendation from this is the current research demonstrated just estimate of the expected flows in the bridge and suggested the appropriate hydraulic section, and to investigate the resulted scour depths at the bridge piers due to the expected flows. The study has shown the effect of flooding on the chosen site of the area. The value of the weighted curve, as we see, was estimated based on the urban development and the land use changes. The hydraulic modeling done by HECRAS to determine the hydraulic characteristics for different sections to include the water levels, velocity, and expected scour depths at the bridge piers Another parameter was considered in the hydraulic modeling, which is Manning roughness coefficient, and this increased to be 0.3 to dissipate, as I told, the energy dissipators as the baffles and drops.
Try to go for it,
okay.
Because you have to.
So at the end, it is recommended to use some accessories to device or devices in the stilling basin to dissipate the energy at the downstream of the valley. Recommended to strengthen also the soil type of the bed to match it with the calibrated value of the roughness coefficient used in the modeling to reduce the flow velocity and hence dissipating the high kinetic energy. Okay, almost done. Thank you very much for this.
Thank you very much, Dr. Ibrahim, for this presentation. I think we should make a deal here that you take 2 minutes more time than what has been assigned or scheduled.
Okay.
But because of given a presentation, so we are even. Thank you very much. We would like to have one question, please. And thank you very much. I was about to say from the email. Okay, go ahead.
Thank you very much, Doctor, for your presentation. I have just simple and short questions, or maybe the first one is not a question, just like you were during your presentation saying all the time we are talking about short duration rainfall. Actually, I think, in my opinion, that the duration is not the problem. It can be a short-term rainfall, but it cannot be very high. So the intensity is, the matter is the intensity of the rainfall. It can be a short rainfall, but high intensity, so it can be damage and effectiveness. And this is one point, so if you can comment on it. I don't know if it's clear or not. Let me finish and then. The second one is, it was not clear for me during the presentation, what about the drainage system in the area of Thumama, I think? Yeah, nothing was for me. I didn't see anything about the drainage, if there is a drainage system or not, and how it acts. Third question is also about the density of the rainfall gauges in this area. Also, you mentioned about the importance of the density of the rainfall gauges in the area to be very useful during the analysis, but it was not also clear for me how many rain gauges did you use, what was the density, and when you say it has to be a good number so we can rely on it. So what is the good number? What is the criteria of being a good number? And the other thing is you talked also about the missed data. If we have missing data also, this is a point that maybe so also there are ways of doing a gut feeling of the data if you have enough rainfall information or nearby stations. The last point is what about validation of this analysis? Thank you very much.
Okay, thank you.
And I wanna come up with that.
Dictator, there was just only one question. I think you asked many questions that should take at least half an hour to answer, or might be extended to an hour. So please answer that shortly, very short and precise. And if there is any further discussions that you can by side discussion on these things.
Okay.
Thank you.
Actually, this is what we are using here on the daily basis. Okay, this is what I have it. But some rainfall data is supposed to be have also short basis, short interval. This is what I mentioned. This because to have more or precise idea of that. This it's better, especially for the storm drainage system, not only for this case. Yeah, for this case, maybe we can satisfy with daily, but for like the storm drainage system, we focus. Maybe we are dealing with time of concentration 30 minutes or 20 minutes. How can you get the peak rate for the rainfall, for example? So if so for this we have it daily, maybe you can disaggregate it to short interval. So this one thing. Actually, about the number of rainfall for this area, about it was 3. But I focus in one station because it has a good long record. The others, I have it, but having short record, short and missing data. This is the reason I exclude 2 of them, and I took only one has more than 40 years, and the record was enough. And there almost very less missing data. Regarding what you said, certain question. This harmonization, I mentioned it. Validation. As a validation, this is the reason I asked for or try to ask for some flow data as a measurement to calibrate the parameters. I didn't find flow data. This is a problem. So do some trial and error to get like expected or the reasonable or the within the limitation of the velocities. To deal with this, then I got the scour at this point for this.
Thank you. Thank you, Dr. Ibrahim. I'll give my colleague, Dr. Mohammed, to introduce the last speaker.
Thank you, Dr. Mansour. The last speaker, Dr. Adil Bushnab, talk about tap rain-making technology using natural resources and solutions. Allow me to introduce Dr. Adil in Arabic. دكتور عادل غني عن التعريف له باع طويل في العمل الأكاديمي والتطوعي والعلمي امتد ما يقارب 50 سنة عندما كان يدرس الهندسة المدنية في جامعة الملك سعود. شارك في تأسيس العديد من الجمعيات الخيرية وجمعيات المياه والتحلية العالمية والعربية والخليجية. ثم أصبح رجل أعمال وشارك في تأسيس العديد من شركات ومصانع التحلية مثل الكوثر والكمداسة ومويا، والآن يخصص وقته لخدمة المجتمع والقطاع الثالث، وهو رئيس مجلس إدارة وقف طيبة المعرفة ورئيس مجلس إدارة جمعية طيبة التعليمية الخيرية، ويعشق استخدام التقنيات الجديدة للنشر العلمي النافع واستدامة الخدمات واحتياجات المجتمع في المياه والزراعة والبيئة والمجتمع. تفضل دكتور. الحمد لله، أنا سعيد أن أكون معكم، وأنه جمعية المياه الخليجية مشيرة بعد أكثر من 30 سنة، ربنا يوفق إن شاء الله. وأنا أعشق اللغة العربية، طلبتي في جامعة الملك سعود يتذكروني من أكثر من 50 سنة أن أنا كنت الوحيد الأستاذ في الجامعة اللي يدرس الهندسة بالعربي. وأنا هذا أتكلم عربي، عربت كثير من الاختراعات المياه زي التناظر العكسي اللي أنا سميتها بما نسب الشركات الأمريكية اللي كانت تملك التقنية طبعا في السبعينات. وأنا سعيد الحمد لله أن مؤسسة التحلية اعترفت بعد 30 سنة، أكثر من 30 سنة، إنه التناظر العكسي أفضل من التقطير الوضعي والأسلوب التقليدي. وهذا ما أعشقه، إن نحن نخترع نطور تقنيات جديدة تفيد أكبر عدد من الناس بأقل التكاليف ولها أثر إيجابي على البيئة. وهذا الموضوع اللي أنا بدي أتكلم عليه، تقنية غيث السماء. غيث السماء لأنه هي يسموها الاستمطار الطبيعي، لأنه معروف من 50 سنة في العالم الاستمطار الصناعي. يجي الاستمطار الصناعي أو طائرات وهليكوبتر وترش السحب الموجودة عشان تنزلها مطر، بس ما في حد يعرف فين حتنزل وايش كمية المطر. ومشاكل الاستمطار الصناعي يمكن أكثر من الفوائد، لأنه الزيادة في المطر نسبة قليلة جدا. في حين الاستمطار الطبيعي اللي أنا حتكلم عنه في العشر دقائق الجاية عشان نكون وقت أكثر لأسئلتكم وإجاباتكم. إن نحن نستخدم وسائل الطبيعة. الرياح لواقع. إيش هي اللواقع؟ هي الأيونات السالبة negative ions. لما الأيونات السالبة تتلاقى مع الأيونات الموجبة في الهواء تتكون قطرة ماء. عشان تكثف القطره هذه وتنزلها مطر لازم تزيد الايونات عشان تكبر القطره. وهذا هو الاستمرار الطبيعي، كله موجود، الرطوبه والهواء والايونات الموجبه موجوده في كل مكان في كل وقت في نسب مختلفه. ولذلك نحتاج اجهزه اكثر كل ما نبعد عن السواحل لان الرطوبه اقل. ايش الاجهزه هذه؟ الاجهزه بتولد ايونات سالبه وتسرعها عشان تصل لارتفاعات عاليه، لانه القطره ما حتتكون الا ارتفاعات قريبه للصفر الديو بوينت. وهذه ارتفاعات عاليه في دول الخليج فوق ال 3000 متر. لكن الميزه انك انت تقدر تكون سحابه في سماء زرقاء، ما في سحابه واحده. الاستمطار الصناعي مستحيل انك تمطر شيء ولا تعمل شيء بدون سحابه، انك تبدا بسحابه. لكن الاستمطار الطبيعي تبدا بلا شيء، لا شيء، تكون سحابه في دقائق ثم تتبعها، لانه هذا هو الاصعب في الاستمطار الصناعي. لا يعرفوا الطائرات والهليكوبتر كيف السحابه تمشي فين عشان يكثفوها ويجعلوها وزن عشان تنزل مطر. الان بالدرونز ممكن جدا انت تتبع السحابه حتى لو غيرت اتجاه الريح، لان السحابه تتبع الريح، تنزلها في الموقع الذي تريد او مرغوب انه ينزل مطر خلف سدود. عندنا 570 سنه في المملكه، كلها هذه ممكن تستفيد منها، وما اكثر مئات الوديان اللي ممكن يخزن لنا مياه المطر في بطون الاوديه افضل من خلف السدود. وهذه كلها بتكاليف اقل من 10% من تكاليف تحليه المياه البحر والطاقه لداخل المملكه. فرق كبير في التكلفه وفي الاستدامه، لانه محطات التحليه لها اثار بيئيه سلبيه، لكن هذه ما في اثر بيئي، بالعكس انت هنا طاقه قليله، يعني بطاريات تنتج هذه الايونات وتسرعها وتستطيع ان تخضر الصحراء، تكون مروج خضراء، وان شاء الله مستقبلا الغابات. وكل الجزيره العربيه، وهذا هدفي الشخصي، ان نحن نخضر الجزيره العربيه وبعدين العالم العربي عشان الجميع يستفيد، المجتمع يستفيد، البيئه تستفيد من التقنيه، مش فقط ضمان استدامه المطر والغذاء والزراعه وحتى الطاقه، لان اذا نزلت المطر خلف سدود عاليه عندك انتاج الطاقه الهيدرو باور ارخص من الطاقه الشمسيه. وما اكثر عندنا الوديان والجبال خلف حولها، بالتالي تكلفه انشاء سد عالي في الجزيره العربيه ارخص من مصر. وهكذا. الشاهد علينا ان نفكر خارج الصندوق الاسود المألوف المعروف. للاسف الى الان نفكر في المألوف المعروف ونتكلم كاكاديميين. انا خلاص تركت الاكاديميه 50 سنه كفايه، واريد ان اكون من رواد المجتمع اللي يخدم المجتمع له اثر بعدي، عشان الاحفاد والاصدقاء يستفيدوا ويتذكروني بالخير ان شاء الله والدعاء، لان الواحد لا يريد الان الا اجر الاخر. الحمد لله اكثر من 40 سنه في القطاع الخاص، لكن انا اسمي نفسي الان القطاع الثالث، لانه اركز كل ما اعمله الان ليخدم المجتمع والقطاع الثالث وليس القطاع الثاني. ونتعاون ان شاء الله كلنا، لانه الفوائد ما حتيجي من شخص واحد للقطاع، بل حتيجي بالتلاقح والافكار عشان كيف نحن نقدر نعظم المنافع من العلم النافع بشكل نجعل فيه استدامه ماليه. يعني ان شاء الله هذه التقنيه اللي يستثمر فيها، لانه الان احسن السنه هذه احسن فرصه للاستثمار فيها، لانه نحن نبغى نثبت الكلام ده بانزال المطر. وبالتالي تعرفوا جهه خيريه ولا حكوميه، لا اريد شركات، لاني تعاملت مع شركات كلهم يريدوا ان يسيطروا على التقنيه، وحاولت وسافرت اكثر من دوله في الخليج، وفي اكثر من مركز وطني، مركز استمطار، كلهم يريدوا ان يسيطروا على ما عندك، على فكرتك، وليس شيء اخر. وبالتالي لا اريد التعامل مع هؤلاء، اريد التعامل مع من يريد ان يساعد المجتمع المحلي ويحول التقنيه الى فائده تخدم اكبر عدد من الناس، وليس شركه فلان ولا شركه علان ولا وزير كذا ولا شيء عشان والله عندنا انجزنا شيء. الانجاز بيجي مع بعض. ان شاء الله الجمعيه تستفيد حتى ماديا، لانه اللي يشارك وقف طيبه للمعرفه اللي هو الحين يملك حصه طيبه في كل ما صرفته انا خصصته لوقف طيب. كل ما اطلب من كل مستثمر الان يخصص نسبه مش شرط لوقف طيبه، ممكن وقف محلي عشان يخدم المجتمع المحلي. المهم انه حاجه خيريه وليست شركه ماليه وتجاريه. طيب انا اخذت في 5 دقائق، عندك مجال. طيب اديني مجال، تفضل. ممكن اقبل الاسئله؟ ايوه نعم.
انا اشكر معلش يا دكتور، يعني غيث السماء الفكره اللي طرحتها فكره عظيمه جدا من ناحيه يعني منطقيه. كيف يعني؟ احنا نعرف انه مثلا العواصف الرعديه دائما تكون ان الهواء يتسخن او يكون ساخن، بس فيه شويه هيوميديتي ويرتفع الى الاعلى، لما يوصل نقطه الندى باذن الله احد اسباب المطر هو هذا. الاشكاليه في الاستمطار الطبيعي او غيث السماء هو عدم وجود نيوكلياي لتكون بطيرات الماء فوق. يعني مثلا حتى لو توفر هواء فيه شوي هيوميديتي وارتفع الى الارتفاع اللازم لبلوغ الندى، لن يكون هناك تجمع للبطيرات هذه الا بوجود ما يسمى نيوكلياي. يعني احد متطلبات المطر سواء باي حاله كانت احد الاسباب او احد العوامل الرئيسيه لنزول المطر باذن الله هو وجود نيوكلياي في الطبقات العليا. ميزه انا لا ادافع عن الاستمطار الصناعي، بس انا اقول العامل المهم في الاستمطار الصناعي لنزول المطر هو وجود النيوكلياي. طيب اذا لم توجد وفقط اعتمدنا على الهيوميديتي اللي في الهواء وارتفاعه الى الاعلى ووصوله الى الديو بوينت، مهما كان كلامك سليم ان هذا ما يعتمد على الرياح ولا يعتمد على شيء. مثلا اعطي مثال، لما تهب الرياح من افريقيا على جبال الحجاز وعسير ويرتفع الاورجرافيك ليفت، هذا يسبب ان الهواء اللي جاي بدرجه حراره 20 او 25 درجه مئويه لما يرتفع فوق قبل ما يوصل قمه الجبل او عند وصول قمه الجبال سيصل الى الديو بوينت. بس اذا توفرت نيوكلياي هناك، اذا لم تتوفر فهذا عامل مهم جدا في عدم نزول المطر. فانا اتصور ان الشيء الطبيعي جيد، لكن اذا لم توجد نيوكلياي يعني كونك ترفع الهواء وتبرده، هذا هو اللي يتكلم عنه بغيث السماء.
سؤالك واضح، بس اديني فرصه اجيب نص الوقت اللي انت اخذته عشان تطرح السؤال. النيوكلياي لما تعرفها ايش هي؟ قطره ماء صغيره، يعني بدايه القطره، وهذا هو بدايه السحابه. عرفها. انا ما احب الكلمات الانجليزيه. ايش تعرف النيوكلياي؟ نواة القطرة. اسمعني نواة القطرة.
البطيرات لابد تتكون تتجمع حول.
اسمعني عشان اقول لك، عشان تتعلم شيء جديد. انت دحين كلامك صحيح، كل سؤالك صحيح، لكن نواة القطرة تتكون بالتلاقح الموجب مع السالب. اذا ما في قطرات سالبه، السحابه اللي ترفع عشان نقطه بيكون تدرج بالعربي نقطه الندى. نقطه الندى عشان تصل الى نقطه المدى. يمكن في بعض المناطق 4000 متر، يعني اكثر من 3000. وبالتالي هذه هي سبحان الله كيف السحب والجبال اذا توفر هذه تكثف السحب وتنزلها مطر. وهذا كله استمطار الصناعي. الاستمطار الطبيعي انك تبدا من لا شيء، ما في نقطه ندى ولا في نيوكليا ولا في شيء. ترسل ايونات، الايونات السالبه هي التي تتحد مع الموجبه الموجوده في الهواء في السماء بكل وقت في كل مكان، عشان لما تتحد تتكون النيوكليات النواه. وبالتالي بعد دقائق قليله حتشوف السحابه في سماء زرقاء، ما في سحب، انت تكون سحابه بارسال الايونات وليس بارسال سحاب. يعني الرياح اللي انت تفضل بها، نعم كل هذه فيها لواقح اللي هي بتمكن ان لما توصل لارتفاعات عاليه تتكون تزداد حجم قطره الماء عشان تنزل نزل ومطر. ما ادري الاجابه واضحه؟ طيب الحمد لله. يعني ارحب بكل الاسئله حقتكم.
اذا احد يا جماعه يعني يستغل هذه الفرصه يستفيد، تفضل.
السلام عليكم. صلى الله عليه وسلم. فكرة يسوي عليها انت، اذا السحابة ما هي موجودة وأوجدتها، إنزالها في مكان معين كيف تصير؟ معلش أنا ماني متخصص في الموضوع هذا برضه.
بنفس الطريقة التي بدأت السحابة، إنه الأيونات تتبع السحابة، لأنه إذا ما تبعت السحابة وكثفتها حتتشتت مع الهواء. فيجب متابعة السحابة يمين يسار وتكثيفها عشان تنزل مطر بالقرب من الموقع الذي أنت تريد فيه المطر.
رجع نفس موضوع الاستمطار، يعني كانت لما يلقحوها وكانت بالطيارات، الفكرة كانت أحيانا السحابة تمطر في مكان ثاني.
لكن المشكلة الاستمطار الصناعي لا يتبع السحابة ولا يعرفوا، يعني أحيانا هذه المواد الكيميائية والأساليب سواء جلود أو كويس، يعني عليها ثلوج قطرات ثلج عشان تكثف القطرة تنزلها. هذه كلها ما في متابعة ولا أحد يعرف الزيادة كم، ونسبة الزيادة في المطر في كل قليلة جدا، ما هي زيادة عالية. الحمد لله عمان بدأوا من أكثر من 10 سنين استخدام الأيونات السالبة لتكثيف السحب.
جميل. أنا الآن فكرتك نسوي السحب جميلة. أنا سؤالي الاستمطار في مكان معين، هذه ما هي حسب الرياح الموجودة. بإمكان أنا أسوي الأيونات وأسوي السحب، فالرياح تأخذها في مكان ثاني. هذا سؤالي.
سؤالك صحيح وجيد. الفكرة علماء الطقس، أنا ماني خبير طقس، يعرفوا اتجاه، يعني الريح اليوم حتمشي من هنا، من جايه من الشرق من الشمال وحتمشي كذا، بكره حتمشي كذا. فهذا كله المعلومات موجوده لخبراء الطقس. والحمد لله عندنا المركز الارصاد الوطني عنده معلومات جيده عن كل العالم العربي مش بس المملكه. هذه حتساعدك انك تخطط. انا حتى لو ما عندك هذه المعلومه، انت تقدر وسائل حديثه تتابع السحابه، تعرف هذه السحابه هنا يمين يسار، انا اوجه الدرون عشان يتبع السحابه. لانه اذا ما تبعت السحابه حتتشتت السحابه، ما في شيء ولا مطر ولا سحاب ولا شيء. فيجب هذا هو الفرق بين الاستمطار الصناعي والطبيعي. الطبيعي انك انت تتبع السحابه عشان تستخدم وسائل الطبيعه عشان تنزل مطر. طبعا نبغى نطبق هذا الشيء في 2022، لانه حلمي انه نحن قبل 2030 نحن نصدر ونصنع نبيع، وهذه حتساوي آلاف الملايين. يعني
I have a conference on. I will check it.
So what is the question? هو المستقبل ان الدرونز حتتدخل في حياتنا.
دكتور والله بس لو تختصر عشان عندنا اسئله كثير بس احنا صراحه الوقت خلص بس اهميه الموضوع بس بياخذ من وقتكم في البريك يعني عندنا ايه فكنت خلينا ناخذ سؤال واحد بس بشكل كلش مختصر عشان البريك يعني انت اختار ايه
السلام عليكم جميعا. علي القصاوي مدير مركز الاستنباط الصناعي في سلطنة عمان. هو مش سؤال، هو تعليق على موضوع الاستنباط الصناعي. احنا في سلطنة عمان عندنا 12 محطة استنباط صناعي بتقنية البواعث اليومية مثل ما تفضل الدكتور. فما في آثار سلبية للطريقة هذه، في نفس الوقت هي ما فيها تكلفة يعني كثيرة حسب المتوقع أو حسب التصور أن تكلفتها عالية جدا. لا، هي المحطة يمكن إذا قلنا احنا يمكن تكلفة المحطة الواحدة في حدود أقل عن $100,000 يعني. والتكاليف التشغيلية أيضا ما هي بالكثيرة مبالغ كبيرة، فهي تظل هي تقنية مثبتة علميا وما فيها تكاليف مستمرة، وكذلك يعني ما فيها آثار سلبية. فأنا بس تساؤل فقط الدكتور وضح لي من نقطة الصفر، يعني أنت تنشئ أمطار من نقطة صفر، بس إحنا المحطات اللي معمولة سلطنة عمان هي مش من الصفر، هي موجودة في مواقع تكونات السحب نفسها على ارتفاعات كبيرة وقريبة جدا من نقطة المدى. فقط عامل الرفع هو الهواء، يعني فقط الهواء الرياح الصاعدة. هي تعتمد على فترات يعني التكونات المحليه مع سلطنه عمان، لكن نسبه التعزيز تقريبا وصلت من 15 الى 18%. في يعني محطات قياس امطار موزعه على قريب محطات الاستنباط، ففي طريقه احصائيه مثبته علميا، والطريقه هذه ما احنا يعني استخدمناها بنفسنا نثبت جدول الاستنباط نفسه. هي جامعه اسكندريه كجهه محاوله في الموضوع نفسه.
شكرا، انا سعيد انه انت موجود معنا وكلامك صحيح حقيقه. الحمد لله عمان سبقت العالم العربي. الاردن الان من سنوات قليله بداوا يستخدموا نفس التقنيه، ابراج كهربائيه عشان ينتجوا البيانات السابقه. أنا أتمنى إن شاء الله أنه نطبق برضه التقنية الجديدة للاستنطار الطبيعي في عمان ولا في أي دولة خليجية أو أي منطقة في المملكة، لأنه كل منطقة حسب الموقع وقربها من السواحل عدد الأجهزة المطلوبة وتكلفة الإنتاج. ولكن الفرق زي ما تفضل كويس إنه كم نسبة الزيادة في المطر زي ما قلت أقل من 18%، أقل من 20%، في حين تقنية الاستنطار الطبيعي تقدر تزيد المطر 80%. هذا شيء ما هو منجز إلى الآن ولا في أي مكان. ليه؟ السبب هو إنك أنت بتتبع السحابة عشان، وهذا المشكلة كمان عندكم في عمان ما تعرف فين المطر حينزل، وال 18 و 20% هذه فين حتى يعني مجرد تقدر تتنبأ إنه والله السحابة حتنزل هنا. لكن كلامك صحيح ما في آثار سلبية، ولكن كمية الزيادة أحسن برضو من الاستنطار الصناعي في المملكة. احنا إلى الآن بنتكلم على 10% أو أقل من 10% في المملكة لتضييق الطائرات والهليكوبتر والمواد الكيميائية، في حين التقنية الجديدة أنت بتتكلم فوق ال 50%. طبعا أنا حطيت 80%، هذا أقصى شيء على حسب الظروف والجو والمناخ والإمكانيات اللي عندك، لأنه بتعتمد على عدد الأجهزة والظروف المناخية. وبالتالي يعني مو حكاية ما في أحد يعني سبحان الله.
دكتور نعتذر، فإذا في أي نقاش بيكون عندنا واحد سؤال للدكتور بيكون في بريك زين، وأي واحد يحب يستفيد من الدكتور. احنا الدكتور بنشكر جزيل الشكر ونتجاوزنا الوقت على هذه النصائح والمحاضرة القيمة، واحنا طبعا أكيد نستفيد من خبراتك وعملك ونكون من عهدك احنا كمتخصصين ما نستمر على هذا العنوان ان شاء الله باستخدام التقنيات والاستفاده من المجتمع ان شاء الله. يعطيك العافيه وما قصرت. يعطيكم العافيه. في بريك لمده 15 دقيقه. شكرا لكم حضوركم ان شاء الله.
الجدول كالتالي: يوم الخميس ما في داعي تينا من الصبح، لازم نحن نتقابل مع الدكتور على الغداء، يعني تجينا على إكبة 12:30.
على إكبة مش على إكسبو.
لا، إكسبو بيكون الساعة 6 المساء.
اوكي.
يبدأ قالت نحن بنروح بنتغدى بنجي نريح نبدل ملابسنا بعدين بنروح إكسبو، يعني بيكونوا شغالين في الفيلد.
اوكي.
مع الدكتور برنت من الصباح.
تمام.
يوم الاثنين من الصباح يكون هولدي.
اوكي. يوم 21.
ايه، وقالت لازم 48 ساعة بحث. يعني انت لو عملت اليوم ما في مشكلة عندك.
لا انا عملت امبارح.
اوكي امبارح متى طلعت النتيجة اليوم؟ اليوم 3.
لا هيبقى اليوم الثالث. يبقى انا مش انا هتغدى معاكم وما ادخل الاكس. ويوم 21 بعمل فحص تاني بس.
اوكي خلاص. اعمل ثاني مرة علشان يوم الاثنين.
ان شاء الله. سعيد.
السلام عليكم.
وعليكم السلام.
أخبارك إيه؟
الله يخليك.
كيف؟
أنا في المكتب.
عدي عليك.
نرحب بكم مرة أخرى في the second session about surface and groundwater session. And we have a good number of speakers, and all the speakers will be online. And all the speakers online now with us. And I would like to make a very important announcement for all speakers. Please, we have to stick to the time, and I will give a notice 2 minutes before your time is ending, and I hope that you will stop after the notice, please. Thank you. So I would like you to join me in welcoming our first keynote speaker, Dr. Ziad Khayat, from the ISQA, and he's from the section of groundwater management in the Arab region. And Dr. Ziad is a coordinator of the Integrated Water Resource Management for Improved Water Security at the Climate Change and Natural Resources Sustainability Cluster of the United Nations Economic and Social Commission for the Western Asia. He is currently at the ISQA renewed concentration on groundwater resource management, which has seen issuance of groundwater abstraction guidelines and a report on groundwater resources in the Arab region. Dr. Khayat today will give a talk about groundwater management in the Arab region. Dr. Khayat, welcome you again, and the floor is yours for the next, I would say 18 minutes with 2 minutes for questions. The floor is yours, please.
Good morning. Good morning. Thank you for that. If you could just confirm when you start seeing my presentation.
Yeah, we see your presentation on the screen now. Just a moment. Yes, please. We hear you and we see your presentation. Start.
Excellent. Okay. So thank you again. Thank you for that introduction. And first of all, I'd like to thank everyone who made it there. And I'm sorry I couldn't be with you today due to the COVID travel restrictions, but hopefully next time we'll meet again in the next WSTA. So I'd like to also thank the organizers. As said, my presentation today will be on groundwater in the Arab region, making the invisible visible. And this is based on a regional report that we are issuing this year to look at groundwater in the Arab region in terms of significance, its governance, its the challenges and opportunities, and some of the key messages. So if we start from globally, groundwater is a very important part. So if we look at the total global water component, we see that out of the 2.5% that's available, fresh water readily available, of that, groundwater is 30%, and the other 69% is glaciers and ice caps, which is difficult to access. And when we look at surface water and other fresh water, it's only 1.3%. So globally, the importance of groundwater is very significant, and it represents one of the most important components of the world's total fresh water. In terms of what people depend on, we realize that more than 2.5 billion people, countless farmers and industries depend on this groundwater. About 50% of global drinking water comes from groundwater, 40% of irrigation comes from groundwater, and 35% of water for industries comes from groundwater. The ease of access to groundwater has made advances in the social and economic benefits readily available. It has a low cost, it's usually safe in terms of exposure to drought, and especially now with more climate change. It's usually high quality when compared to surface water, and it has high benefit for agriculture use. And definitely achieving the goals of the 2030 Sustainable Development Agenda will greatly depend on access to this groundwater. So it's no surprise that UN Water has set this year to be the year of groundwater. And on March 22, the global celebration of World Water Day will be marked this year with the theme of groundwater, making the invisible visible. And we will also have a groundwater summit. The UN Water will have a groundwater summit in December, 7 to 8 December in Paris, also to highlight the importance of groundwater globally. So we at ASQA also issued a report along this to inform global platforms and foster regional consultations on groundwater. And we hope that this report will provide a status update on groundwater resources in the region, its major stresses and uses, and hope to improve understanding and raise the awareness to the general public on the importance of groundwater as a strategic resource in the Arab region. Now, in the Arab region, we saw the importance of groundwater globally. We know that the Arab region is one of the most water scarce regions in the world. And currently there are 19 countries below the water scarcity threshold of 1,000 cubic meters per day. And there's an increased dependency on groundwater. We currently see that more than half of the Arab states rely heavily on groundwater. More than 50% of their water comes from groundwater. And this will increase with the projected climate change and the variability of more and more of surface water. Also, groundwater in the Arab region has another characteristic, and that it's that there are 43 transboundary aquifers. All of the Arab countries share one or more a transboundary aquifer, except for Comoros. And when you look at the map, you see that transboundary aquifers cover almost 60% of the Arab region. So that requires a special type of cooperation and integrated management for that. Furthermore, we see that more than half of the groundwater resources in the region are non-renewable. And the use of these shared non-renewable aquifers is usually not well planned or regulated or monitored. And again, with the combination of non-renewable aquifers, transboundary aquifers, there's more and more of a need of an integrated management and planning to avoid this over-exploitation. And I think Dr. Amjad will also talk about transboundary aquifers in this session. Now, in terms of uses of the groundwater in the Arab region, agriculture is the biggest consumer of groundwater. In some countries, over 88% of all irrigation water comes from groundwater compared to a global average of just over 37%. And this is combined with a low efficiency in irrigation. In the region, the efficiency for irrigation is around 50 to 60%. And when you compare it to other places where they have similar climatic conditions, it's 80%, for example, in Southwestern United States and Australia. So we have a combination of non-renewable aquifers, a high usage of this groundwater in agriculture with a very low irrigation efficiency, which is a very dangerous combination, which is depleting our groundwater. Now, also tied to this agricultural use is also energy. So we know, we all realize that groundwater exploitation is very energy intensive, and the deeper the aquifers and the fossil aquifers in the region, the higher the energy intensity. And as you can see from this map, the irrigated areas which are in green have a combination of a very dark red color, which shows the energy intensity. And this is a clear indication of the nexus between groundwater, energy, and food and agricultural food security. So what is unfortunate that in many of the Arab countries, this energy has been subsidized, leading to a low cost and over abstraction of groundwater. And this stresses the need for, again, integrated policies across sectors. What we have seen in recent years is to lower the energy bill through the use of solar energy and solar pumping. And this has actually, when it's not well planned and not combined with well policies, it has led to further and further decline, where now the energy source has very little cost except for the initial cost of the system. And in many places, it's being afforded through either donors or through green loans with low interest and low cost, which is leading to more over exploitation. Furthermore, if we look at all of these uses, and we've done a sort of a regional assessment using satellite data, GRACE data, we can see that this groundwater stress is expanding more and more in the region. So when we compared between 2002 and 2011, the area in the Arab region witnessing a storage decline increased by 75% compared to the 2002 year. And then when we looked at 2018, it doubled. The area that's witnessing a storage decline, it has doubled. So we can see that there's a decline, that stress over the entire region. And also we are seeing more and more seawater intrusion in coastal cities. This is an example from Lebanon, where this urbanization in these coastal cities is leading to groundwater depletion and also affecting the groundwater quality through seawater intrusion. So when we looked at this population growth by 2050, 17 states in the Arab region will be below the absolute water scarcity threshold, which is 500 cubic meters per year. And we can see from the lower blue line that groundwater will also decline availability per capita to less than 40% of what it is currently in that sense. Other stresses on groundwater that also are increasing are climate change. Climate change affects groundwater directly through a decrease in precipitation and thus a decrease in recharge, but it also indirectly affects it through an increased demand on groundwater. With the decline of available precipitation and surface water, more and more people will turn to groundwater, and this is affecting the availability of groundwater and the water levels. And we did modeling in Palestine and in Morocco on the impacts of climate change. And the results showed that there's a decline in Morocco in the Ben Amir Aquifer, where the groundwater table declined between 10 and 25 meters. And I think Dr. Abdel Qadir Al-Arabi presented this on the first day. And in Palestine, in the Usain Aquifer, the groundwater levels declined by mid-century by 15 to 35 meters in the aquifer. And this is a big challenge, as groundwater will be relied on more and more with climate change. Another impact of groundwater, and we see this in many of the Gulf cities, is the groundwater rise due to over-irrigation or due to leakage from wastewater or water networks, and that's also another stress on the environment. With all of that depletion and all of these stresses, the transboundary aquifers, one of the most important tools is the groundwater management, the groundwater governance. Unfortunately, there's a lot of challenges in the region on groundwater governance, and these, for instance, include inadequate groundwater-specific policies and lack of political will for their implementation when they exist, weak groundwater institutions and limited funding for these institutions, inadequate understanding of groundwater systems. This is a big problem in many places, and especially on transboundary aquifers. There's limited community participation, and there's usually lack of information coupled with weak monitoring systems and technology. And this was evident in a recent Arab regional report that we did on SDG indicator 6.5.1 on IWRM. And only 9 Arab states have reported adequate implementation of groundwater management according to this indicator on IWRM implementation. And financing was the weakest component of IWRM implementation in the region. We also looked at transboundary aquifer management, And as I said, all Arab states share an aquifer except for Comoros. There are some good examples of cooperation in the region, like on the Northwestern Sahara aquifer system shared between Algeria, Tunisia, and Tripoli, and Libya. There's also a good example on the Sakram Disi aquifer between the Kingdom of Saudi Arabia and Jordan. There's other examples on the Nubian sandstone aquifer system, and more recently on the Senegal-Mauritanian aquifer. But one of the major challenges in transboundary aquifers is the lack of data and understanding of these large aquifers, these large regional aquifers. And there's a large need for improvement in data availability and understanding of these transboundary aquifer systems to improve cooperation on these large aquifers in the region. Now, what we've done in these last few years in terms of trying to assist countries is looking at several fronts, looking at improving the data availability, looking at improving the management tools. And one of the things that we did is we did a survey of the policies and the legal environment on groundwater pumping, groundwater abstraction management in the region. And we combined these into a guide on the management that countries can look at as a guideline on how to improve their national legislations. And with this guide, we also availed a tool of indicators that they can do a quick assessment on the national policies and to easily identify areas for improvement. And I provided a link for those that are interested to look at this guide. We also have looked a lot into using innovative technologies, what's called disruptive technologies for groundwater management. And we have a partnership with the World Bank looking at these disruptive technologies. So this is looking at satellite data, looking at telemetry, remote sensing, and combining these different sources for the benefit of availing more data more easily, and then integrating this technologies with in situ data and trying to see this combination and how this can help in availing data and in improving the management of groundwater in the region, especially when you have large aquifers over vast areas. And we know that it's very costly to collect data and improve the management for these. We've also tried to highlight the importance of managed aquifer recharge in the region as a solution to increase and maintain groundwater levels or to improve groundwater quality and improve water security. And we looked at tens of MAR sites in the Arab regions, and it seems that the recharge dam is the most common type. And we also, on a regional scale, we've identified 8 preliminary sites using satellite data, and of course this has to be combined with in situ further analysis to look where there's a decline in storage and how MAR can help in improving that decline in storage. We are also launching this year, we will start working on an Arab groundwater digital knowledge platform with our partners AXAD. And it will be a dedicated digital interactive platform on groundwater. Its aim is to increase and improve access to regional knowledge and information on groundwater, and help the groundwater resources management and regional stakeholders in management of this resource. And it complements other knowledge platforms and networks that ESCO has, especially on climate change. And this is stemming from all of the recent workshops, the reporting on IWRM SDG indicators, on Transpondery SDG indicator 652. There's been, all of the countries have identified that the lack of data and information availability and accessibility to this information is a major hindrance to the improvement of groundwater management. And this is why we have looked at this Arab groundwater digital knowledge platform to sort of help the countries with accessing this data. In the end, I'd like to leave you with some key messages that we've issued in this report that's coming up. And we've sort of divided these into different priority areas. So on groundwater and water scarcity, we know that action by countries has not been able to address the groundwater challenges, which underscores the need for immediate action on several fronts, including socioeconomic, environmental, and governmental fronts. The business as usual model can no longer be tolerated. The immediate changes are needed, and we hope that this being a groundwater year, SWGN Water Groundwater Year, will help to start this transformation in how we manage our groundwater. We also highlighted the use of integrated tools that offer great opportunity. Yes, wrapping up, 1 minute probably. So integrated tools offer a great opportunity for adequate groundwater management. And we also highlight the importance of managed aquifer recharge as a promising approach to alleviate water scarcity and improve water security. In terms of groundwater and the human activity, we stress the importance that management of groundwater should extend into a coherent cross-sectorial governance approach. It's no longer accepted that we manage groundwater only by specialists like us, only in the groundwater. It must extend to other sectors, as groundwater depletion impacts activities and affects several vulnerable groups. And also groundwater quality is important to highlight, as it's affected by other sectors such as agriculture and industrial activities, and by cities, as we see through seawater intrusion. In terms of groundwater, transboundary groundwater, we stress the importance of transfer of experience and knowledge from regional groundwater cooperation arrangements to accelerate progress at the full regional scale, and also the importance of improvements in data availability and understanding of transboundary groundwater systems to preserve this vital resource for future generations. So leveraging innovative approaches and technologies can help fill the gap in data. Looking at climate change and groundwater, we realize the importance of groundwater as a buffer for climate change with the decline of available surface water and other traditional water sources. But we also realize that there's insufficient action recognizing and acknowledging the role of groundwater in this climate change resilience. And most of the climate change funding and projects are going to surface water and big projects as dams, and not enough attention is being put on groundwater. In terms of groundwater governance, there's a need for good information based on sufficient and reliable data with the needed investment to produce useful knowledge. And we call on all partners and all countries to benefit from the regional data platform, groundwater data platform, and the groundwater abstraction managements, and cooperate with us and partners so we avail more information on this groundwater. At the end, I wanted just to leave, I hope we were able to reach this message that the importance of groundwater for the Arab region's water security under a changing climate demands improved governance through innovative management approaches, enhanced use of technologies, and dedicated funding for better understanding of the resource and heightened regional cooperation. So more information on this lecture is available in the ESCO Water Development Report 9. And I'd like to thank the team that has put together this publication and has worked on it throughout the last year. And a big thank you to the coordinators and the organizers of the 14th WASFA conference. And thank you again. Thank you.
Thank you very much. Thank you very much. So we have time for 1 or 2 questions, if any, from the audience. Please.
Thank you, Dr. Khayat, for this valuable presentation. You said that there is 10 sites of managed aquifer recharge in Arab countries. Where are these sites? We know that in Qatar, Emirates, where are another 10 sites? You hear me?
Yes, I hear you. The sites, there are several sites in the Gulf region. There's sites in Saudi Arabia. There are sites in Morocco, in Tunisia. There's more details in the report on these sites and where they're available. There's a map of them. If that, I can share that with you. And these are the sites that we were able to find records of. I'm sure there's more sites that are not officially reported or have not been recorded. So, but we hope to be able to capture all of these sites and also include them in the digital platform with more information on them. So if we were able to identify specifically location and data on 44 sites across the Arab region. Once we make these available, if you are aware of other sites, we would love to have more information on them. But I do draw the attention that some of these sites are part of the national water security, and information is a little bit difficult to access for information on that. UAE has sites. Most of the Gulf countries have recharge sites. We found in most of them recharge sites.
Thank you very much, Dr. Khayyat, and I would like to excuse the audience to move to the next presenter, as we are a bit lagging in time, and I hope that Dr. Khayyat will be with us maybe toward the end of the session. If we have time, then we can also receive some questions. Thank you very much for your valuable presentation.
Thank you. Thank you.
Thank you. Now let's move to the second presentation by Dr. Mohammed Dawood from United Arab Emirates, and his presentation will be about using electricity consumption as a tool for groundwater abstraction in Abu Dhabi Emirates. Dr. Mohammed Dawood is a professor and a senior water sources advisor with the Environment Agency in Abu Dhabi. He has more than 25 years of experience in groundwater aquifers, artificial recharge with desalinated water, wastewater reuse, salinity technology, and many aspects. He has 7 published books and more than 80 published research papers in international peer-reviewed journals and international conferences. And he received recognized awards of Abu Dhabi Excellence Award and 2011 His Highness Sheikh Sultan Zayed Al Nahyan Award, and in 2012 he also awarded the National Academies USA as one of the best for young Arab water scientists. Dr. Mohammed, welcome you again, and the floor is yours for the next 15 minutes, and I would like to appreciate that to stick to the time for 12 minutes and 3 minutes for questions. Thank you.
Thank you, His Excellency, your Chairman, and good afternoon, everybody. Today is this continuous speech about what have been mentioned by my colleague, Dr. Ziad from ESCWA, about how we can manage and regulate the groundwater resources in arid region, and how we can overcome the challenges and the both mitigation measure to minimize the deterioration and the exploitation of our non-renewable groundwater aquifers. In general, in Abu Dhabi Emirate, we have 3 resources. The first one is the groundwater, which is contributing by about 61% out of the total budget of the Emirate, and 30% is coming from desalinated water with some environmental and economic constraints. We are reusing now about 55% out of the total treated wastewater reuse, which is contributing with about 9%. However, there is a plan by April 2022 to utilize all the treated wastewater to reach zero discharge to environment, which will increase this percentage to 13% or 14%. This water resource is used in many different sectors with a total water supply of about 3.5 billion cubic meter a year. The groundwater is used mainly for agriculture, and 91% of the groundwater is used for agriculture, and the remaining sectors, and also this agriculture or irrigation is including either farms or forests, and we do have about 24,000 farms and about 320 forested area to improve the our environment in Abu Dhabi Emirate. The domestic sector, commercial, industrial, and other sectors are mainly rely on the desalinated water. We do have a lot of challenges facing our ground or our limited and scarce groundwater resources, and especially its non-renewable aquifer system. The first one is the aridity and scarcity. If, of course, we are an arid region, we have no rainfall, we have no permanent surface water bodies like lakes or rivers. So we do have a lot of challenging getting our aquifer to be recharged. And we have a very limited recharge through boundary flux from Al-Hajar Mountain in Sultanate of Oman. And this is very limited volume, estimated up to 90 million cubic meter a year. However, we are abstracting 2.1 billion. So the recharge is something like 1/15 of the total abstraction. We have some legal and institutional fragmentation. However, our new strategy, which have been launched last year, trying to overcome this challenge. We have also a lot of external challenging and also internal challenges, over abstraction, the pollution, and the non-regulation, which we are trying to overcome by the new issued law, which is law number 6 for 2016, and its executive orders very recently. The climate change, have been mentioned by Dr. Ziad, also have affected or will have an effect on the future use of groundwater, either on the supply or the demand side. Groundwater resources and groundwater are highly interlinked with our food security and also our energy security, because we are also depending by 30% on the desalination, and unfortunately our self-sufficient ratio for food supply in Abu Dhabi Emirate is less than 14%. This means that we have a lot of dependency on importing food from other side our emirate. In Abu Dhabi Emirate, as I mentioned, we have more than 24,000 farms. Out of them, about 18,000 farms are irrigated with groundwater, which is either brackish or saline water. And 2,200 farms are irrigated with desalinated water. About 3,700 farms are irrigated with blending of desalinated water and groundwater, and 143 farms are irrigated with treated sewage effluents. As I mentioned, by April 2022, this number will increase to about 4,200 farms will be irrigated by treated sewage effluents to replace some area. 2,200 irrigated with groundwater and 2,000 are irrigated with desalinated water. We have more than 118,000 wells, and you can imagine this huge number of wells. Out of them, 54,000 wells are operating wells, and the really highly production wells are estimated to be 30, or are inventory to be 31,000 wells. This is showing us the condense of the existing wells in the farms in Abu Dhabi Emirate, and this is one. This is just 5 kilometers by 5 kilometers, and you can imagine within this 5 kilometers by 5 kilometers, we have hundreds and hundreds of wells exist in very small areas for non-renewable aquifer system, abstracting a huge amount of water. This is led to the deterioration of groundwater, and this is showing the salinity of groundwater aquifer, and we have only 2 fresh lenses. One through our border with Sultanate of Oman because of the recharge from Al-Hajar Mountain, and one fossil area, which is Liwa, and one in this site is used for aquifer recharge, have been mentioned also by Dr. Ziad in the previous presentation. This is one of our locations for aquifer recharge. It's actually the biggest regional aquifer recharge project at present in the Arab region. This led to the deterioration of the aquifer system and the drop in water table, which we already started to have what we called it deteriorated areas, this red areas, and we started to prevent any new development, any new farming, or even licensing, any new drilling in any new wells in this area. So we have a lot of limitation on drilling of the new wells. And one of the recent challenging facing us is to how to estimate the groundwater abstraction. These 54,000 wells are not equipped with no flow meter. We don't have any flow meters, except a very minor number. It's not exceed 2,000 wells have some flow meters in some governmental farming areas or for forested areas. All private farms have no equipped or not equipped with water flow meter, so it is very difficult for us to estimate the real abstraction. So we started to assess how we can assess the groundwater abstraction, and we selected 9 farming districts in Al Ain area and the Western region area. This is Nahil, Ghammad, Al-Anqa, Al-Dahriya, and Al-Ajir, Al-Wagan, and Al-Wagan South. And we selected many farms within these 9 districts, and we started to measure the electricity consumption and interlink it with the water flow, and doing the necessary calibration to measure exactly what will be the relation between the energy consumption and the water abstraction. And we find there is a correlation and link between this energy consumption and the abstraction. And this shows us one of this area, which is called Al-Ushush. Within Al-Ushush area, we have more than 926 farms at present. And we started to estimate the average daily consumption in some random wells. And we estimate also the consumption of the electricity. And we find that the average use daily for each farm is about 246 cubic meter a day. And the minimum was 5, and the maximum was 622. So the total estimated daily consumption was 228,000 cubic meter. It means that within this districts, we are abstracting about 83.2 million cubic meter a year. We use the same procedure to be applied in many areas, and we find that this could help us to estimate the whole Emirates groundwater, and we find that we classify even the aquifer layer, which is from different wells depths, and we find that most of wells, or about 90% of the wells, are abstracting from the shallow aquifer system. We have two aquifer systems, the consolidated deep aquifer system and the shallow aquifer system. So the most of the wells are pumping from the shallow wells, which its depth ranges between 0 to 150 meter, not more than this. And 80% are used for farming, and some about 12% are using for forest. This means that about 92% are used for irrigation, and the remaining are used for other purpose. This helps us to classify based on the number of farms and the electricity consumption, which we got it from Department of Energy, to estimate the groundwater distribution and the groundwater abstraction distribution in many districts area. And this is showing the numbers in different area in Al Ain and the Western region or Al Dhafra region. This has helped us to put some mitigation measure for managing and controlling and monitoring. So we developed a new monitoring system, and we have now more than 240 monitoring systems to monitor. And also there is a plan now to equip all this water flow or all these wells with water flow meters within the next 5 years. The plan has been approved by the government, and nowadays we also get the initial budget to start equip all these wells, or mainly the production wells, which is flow rate is increasing or exceeding 10 cubic meter per hour with flow meters, and to develop a central database for groundwater management to enhance the management and the efficient use of groundwater for future generation. With this, I would like to thank you, and I'm ready for any question or any clarification.
Thank you very much, Dr. Muhammad, for this very nice presentation, and also for using the time efficiently. The floor is open for questions. Can you check also if there is any question or not? Questions from the audience here first?
Thank you, Dr. Mohammed Dawood. How are you? This is Dr. Ahmed Ziyad. Okay. My query regarding how to meter the agriculture pumping at the medium and the deep wells, and what the technique which you really illustrated regarding the indirect monitoring methods using this electrical energy. So can you give just indication about the techniques? And also, can you give us how can you quantify the metering cubic meter, which was stated at 82 in 2019? Thank you, Dr. Dawood.
And unfortunately, I hardly hear your question because of the sound. But if I understand, you are speaking or you are asking about the metering the groundwater wells, and also about how you will interlink the energy consumption with the water flow. Am I right?
Right.
Yes.
In terms of flow meter, we started to float a tender now, and we get an offer from different 5 suppliers from Germany, from Australia, from Holland, from United States, and from Italy. And we have an agency called Quality Control and Conformity Agency. We worked with them together to develop guidelines and specification for metering for groundwater wells, and the conformity plan was issued also to select the proper brands of water flow meters for groundwater. And also we classified the groundwater wells to productive and non-productive to minimize the cost of installation of meters. Any wells whose rate of flow is less than 10 cubic meter will be classified as low discharge wells, and we will not equip it with groundwater flow meters. In terms of the one which is increasing 10 cubic meter will be classified as medium or highly productive, and it will be equipped with flow meters. We find that 31,000 wells need to be equipped with groundwater flow, and as per the capacity of the suppliers of water flow meters within Abu Dhabi Emirate and United Arab Emirates, we could find that they could provide us with 1,000 water flow meter a month. Based on this, we bought a 5 years plan to equip all our wells, the productive and the medium and the highly productive wells with flow meters. In terms of the interlink between the electricity consumption and the flow, I can send you the detailed paper which I submitted to the conference, and it will be published in the proceeding of the conference, and it will be available shortly on the online. But I can also share it with you. You have a lot of details about how how this has been interlinked and
very clear, Dr. Mohammed, very clear. Very clear. I'm sorry, just I'd like to kindly ask audience to ask questions and the speakers to shorten the questions and also the answers. One final question, maybe Dr. Mohammed, if any. Okay, so with that, I'd like to thank you very much, Dr. Mohammed, for your presentation again. And now we move to the third speaker in our session. Dr. Amjad Alawi from Kuwait. Dr. Amjad is a senior researcher at the Water Research Center of Kuwait Institute for Scientific Research. He published a large number of research articles in international journals and conferences. He worked for more than 20 years as a professor in water resources engineering at Newcastle University in the UK. Dr. Amjad will present today a talk titled A Numerical Approach for the Evaluation of Sustainable Yield of Shared Aquifer Basins, Case Studies from the Arabian Gulf and Eastern Mediterranean countries. Dr. Amjad, welcome, and please, the floor is yours for the next, I would say, 12 minutes, because we need to spare time for questions. Thank you.
Okay, thank you very much, Doctor. Do you hear my voice? Just to check.
Yes, we do, please.
Okay, so my presentation today is about a shared aquifer, transboundary aquifer, as Dr. Ziad mentioned, in the Arab region. And we have quite a number of research activities in this direction. And we would like to share with you the results of one activity. And also, to be honest, it is not everything, but it's just what the time allows us to present today. So I will talk about this area where in Palestine, where this aquifer, there is a number of about 8 aquifers, aquifer basin shared. I am going to take the one in white color here in the figure, and that is a transboundary aquifer, and also it is shared with Egypt. Before I go into some detail about how we managed the sustainable yield of this aquifer basin, I just would like to show that this aquifer basin starts from here in the Ramallah area,
and goes to the Mediterranean Sea and also continues to Egypt. And it has majorly 2 aquifer units, and the total thickness of those aquifer units about 800 meters, and it is dolomitic limestone. So basically it is a very productive aquifer zone. So the aim of this presentation, I mean, why we are conducting such research is because when there is a transboundary aquifer and there are a number of riparian countries benefiting from this aquifer basin, we need to know what is the potential productivity of this aquifer basin. In other ways, how much each country can take from this aquifer basin, abstract from aquifer basin for different uses, whether it is agricultural use or domestic use, or even industrial use. It is very important also, as Dr. Ziad mentioned in his presentation, to establish a governance system for managing those transboundary aquifers or shared aquifer basins. And also, we completed recently another research based on a numerical modeling to establish a suitable governance for shared aquifers between three GCC countries, basically Saudi Arabia, Kuwait, and Iraq. So it is important not only to determine the sustainable yield of the aquifer basin for the sharing countries as a whole, but it is also important to develop a governance system that controls the abstraction and use of the aquifer system by the riparian countries. So the methodology to use determining the sustainable yield of the shared aquifer basin, the transboundary aquifer basins, is first to determine the geometry of the aquifer. The spatial distribution, this is a cross section. So basically we are interested to know how this aquifer unit is distributed spatially. Look here, we are here in the top of the recharge area, around 1,022 meters above sea level, and here we are at the sea level. So, and how that is distributed from the mountains here to the Mediterranean Sea, and from the other locations to other sharing countries. So we managed to utilize many geological cross sections, and we also utilize the seismic data, basically the isobach maps, to determine the thickness of the utilized aquifers in the transboundary aquifer basin. And then the other point is to determine the hydraulic properties of the utilized aquifer units of this transboundary aquifer basin, and we conducted a large number of pumping tests in the shared aquifer basin. And also, when we get the hydraulic properties of the aquifer basin, we needed to eliminate the areas of uncertainty where we are not sure about the hydraulic, the values of the hydraulic parameters. Then we conducted a comprehensive calibration process. And this is the shared aquifer basin by 3 countries. And this is the upper unit, this is the lower unit, and this is how we made the simulated water levels almost matching the observed water levels from the field. And then we came out with an idea about the hydraulic conductivity of the aquifer. And you need to know that this aquifer is unconfined in some parts. Yeah, here it is unconfined. And this one is unconfined here at this area, and it is confined here. This one is unconfined here, and it is confined here. So the aquifer changes from being unconfined in some locations to being confined in other locations. So those hydraulic properties of storage coefficients, specific yield, transmissivity, hydraulic conductivity, total porosity of the aquifer, etc. You need to make sure that you get a clear idea how they are distributed, especially so that you can represent a good picture of the conceptual model that you need to develop the numerical model for it. And also this aquifer is in contact with the sea. So there is in some areas saltwater intrusion, and in some area there are submarine groundwater discharge. So that needs to be taken into account. So the idea is to conduct, I mean, there are two ways to do. Either you do steady state modeling to the shared aquifer basin, or you do a transient calibration. I mean, you develop a transient model, and then you calibrate for storage coefficients, and you create a steady state, and you calibrate for the permeability and the isotropy ratios or coefficients. In this particular study, we only used the steady state. I mean, fortunately, this area is very rich of data. I mean, it was from 1930s, where water levels were measured in the well, in the observation wells, and then up to recent years, where all the stresses of the aquifer can be determined from recharge and from pumping, from saltwater intrusion, from recharge from treated wastewater, recharge from untreated wastewater, recharge from leakage. So you need to look at all components, but for this particular study, we did only steady state calibration in order to come with an idea about the steady state sustainable yield. Of course, we did later the dynamic sustainable yield of the shared aquifer basin, and there is about 150 million cubic meter per year difference. But we need first to establish the steady state sustainable yield of the aquifer yield. Now,
2 minutes, Dr.
okay, I say that quickly. Luckily enough, we have two big springs here and here, and that is the direction of the water flow in this aquifer basin before drilling any well in the aquifer basin. That is 1930s, and we had a lot of data about the discharge of the two major springs, and we managed to make a steady state calibration looking at the discharge of the springs. I mean, if you think about it, if you can model the discharge of the springs correctly and all meanings of recharge to the aquifer basin before development, then that is your sustainable yield. And this is what we actually did. We modeled that using the visual mode flow, and for the upper aquifer unit, lower aquifer unit, and the aquitard between them, and we made a water balance for the entire aquifer, and then we came with a conclusion that the sustainable yield is about, this is the steady state sustainable yield, about 57.9. The dynamic was about 450. after putting wells into operation in this huge aquifer basin. And I shall conclude that using numerical models to establish the steady state sustainable yield of shared aquifer basins and the dynamic sustainable yield of the shared aquifer basin is very useful and can lead to results, and also that needs to be assigned with a system of governance that controls the utilization of the shared aquifer basins. By this, I say thank you and ready for any questions.
Thank you very much, Dr. Amjad, for this presentation. And the floor now is open for questions from the audience, please.
Assalamu alaikum wa rahmatullah. Thank you very much, Dr. Amjad, for this informative presentation.
Thank you.
I just like you mentioned two naming. In the first, in the Palestine and Egypt, you mentioned the name of Transboundary Aquifer, while in the aquifer between Saudi Arabia, Kuwait, and Iran is a shared aquifer. And I'd like to say that the naming of shared aquifers is not agreed all over all. What I mean by the naming, we discussed this matter in the Arab League, and the international naming from the UN is the Transboundary Aquifers. Sharing aquifers is not the right naming. So this is the case, and I think that maybe you know the case. And there was a lot of dialogue on the naming of sharing aquifers. Thank you very much.
Okay, I do not disagree with you. I agree with you. I think we should use transboundary aquifers as you suggested. No problem.
Any question from the audience here? Can you check the online as well? But make it short question, please, Dr.
Thank you, Dr. Amjad. I have one question, simple question. What is the future planning for reduce or minimize the over-exploitation from this groundwater in this area?
I mean, if you establish an efficient governance system, then, but that is, I mean, effective governance system has to be agreed with all riparian countries, and there will be, I mean, a top-level committee to control that governance system. Then that will save the transboundary aquifers forever. I mean, you know, I mean, our country is full of political disputes, and but when it comes to technical issues, the countries should agree on the governance system that will help all the riparian countries to solve their water problems together. It is regional cooperation is the solution to preserve the transboundary aquifer basins by implementing an effective governance system that you should not pump from this transboundary aquifer basin beyond its sustainable yield. So this aquifer basin, the steady state was about 350. The dynamic, I mean, with the wells in operation is 450. All the three sharing countries should not pump from this aquifer basin on yearly basis more than 450 cubic meter per year. That is the solution.
Okay, thank you, Dr. Amir. I think there might be a question online, but please, if there is a question, please answer it shortly. There is a comment. UNESCO is informal and scientific report to refer to this case as both Transpondery and Riyadh. So this is a comment from Prof. Waleed. It's not a question, but just sharing information from his side. And with that, Dr. Amir, I'd like to thank you because we have to move to the next.
Thank you very much. Thank you.
And as a final remark from my side, because I'm a modeler, there is no need to respond to my comment, but I would rather go for transient system and modeling rather than steady state, because it's misleading for having a strategic decision for sustainable yield. Thank you very much again, and now we'll move to our fourth presenter, and we are having Shahad Al-Yaqoubi from Sultan Qaboos University. And Shahad, she's a PhD student, graduated from Sultan Qaboos University, holding her BSc in water technology from Sultan Qaboos University, as well as her master in 2020. And she is now again, as I said, a PhD student. She published, I guess, for around 2 publications. She will present today a talk titled Understanding Saline Water Dynamics in Coastal Aquifers Using Sand Tank Experiment and Numerical Modeling. Shahad, please, the floor is yours for the next 12 minutes. Please stick to the time.
Thank you, Dr. Ali. Actually, I cannot share my screen because there is someone sharing his screen.
Dr. Amjad, if you are around, can you stop sharing? Okay, so try now. Try now, Shahad. So put it in the show. Okay, start please.
Assalamu alaikum. Hi everyone. It is a pleasure to present at 14th Gulf Water Conference. My name is Shahad Al-Yaqoubi. I am PhD candidate at Sultan Qaboos University. Today, I will present about understanding saline water dynamics in coastal aquifers using sand tank experiment and numerical modeling. This presentation is structured as follows: first, introduction, then methodology, results, and finally, the conclusion and recommendations. First of all, as we know that groundwater is the main source of fresh water in arid regions that are characterized by limited of water resources due to the low rate of precipitation and high evaporation. So more stresses are exerted in coastal aquifers due to the expansion of freshwater demands by municipalities, industries, agriculture, and aggravated by population growth. Management of coastal aquifer is of high importance to sustain its usability for water supply. One of the main threats to degradation of water quality in coastal aquifer is the seawater intrusion. Gaining a better understanding of seawater intrusion is important for efficient and sustainable management of groundwater resources. Seawater intrusion is affected by different hydrogeological and hydrological parameters, such as the hydraulic conductivity of the aquifer, abstraction rate, recharge rate, and also the density of seawater. In many coastal aquifers, seawater intrusion is increased by overpumping of fresh water and limited of natural recharge. So seawater intrusion can control and mitigate by implementation of physical barriers, such as the subsurface dam and cut-off walls, and also can decelerate by using managed aquifer recharge. So the objective of our work is to study the impact of different hydraulic gradients and MAR by using injection wells on the dynamics of saline water interface by using sand tank experiment, and numerically by using seawatt code study the effect of hydraulic conductivity on the efficiency of MAR in mitigating seawater intrusion problem. Let's move to laboratory methods. This is the design tank which utilized in our research. is designed and fabricated by using 2 millimeter thick of transparent acrylic sheet. And the dimension of this sand tank are 100 centimeter length, 60 centimeter height, and 15 centimeter wide. This tank is designed to have a water compartment at the left side to represent the fresh water boundary of upstream, and also another water compartment at the downstream to represent saline water boundary. Also, this tank is the water compartments in this tank is designed to have control valves that allow the selection of different hydraulic gradients across the tank corresponding for different runs. Two tanks of 50 gallons are connected to this tank to supplying both fresh water and saline water. Also, we use liquid flow controller to measure and control the inflow rate of water into the tank, and also to know the total volume of fresh water and saline water during the experiment. After we pack the tank with a homogeneous layer of artificial sand, we use this tank for experimenting the dynamics of saline water interface under different hydraulic gradients. The value of hydraulic gradient shows in this table, and also we use constant concentration of saline water for all runs, which is around 50 grams per liter. During this experiment, we monitored and measured the saline water interface intrusion and retreat by using ruler fixed along the bottom of the tank and along the vertical seawater boundary. Also, we recorded the saline water interface toe position, the depth of the interface, discharge zone, and the seepage phase for all runs. As I said before, we control and measure the inflow rates of both fresh water and saline water by using flow rate controller. In addition, we calculated the areas cleaned from saline water for all experiments by using Mathematica 5 program. And finally, we compare the results for each run by, when the system reaches the steady state. The second experiment, we use the same sand tank, but for experimenting the dynamics of saline water interface under the injection well. During this experiment, we fixed one injection well at the middle of the sand tank and at 42 centimeter depth. And then we injected around 1.06 liter of fresh water to retreat the saline water interface backward direction. We monitor and measured the level of the water table by using water level sensor, and we collected water samples from drainage boards and the piezometers to observe the change of the salinity concentration of water under the injection. We monitor and measure the discharge rate of both fresh water and saline water across the tank by using flow meter and graduated cylinder. For numerical approach, this is a conceptual model for seawater simulation. We assigned no flow boundary at the bottom and the constant head boundary for both saline water and freshwater boundaries. So after we did the calibration, we used CWAT code to simulate the laboratory experiment, which I discussed in the previous slide. And then we explore the impact of the hydraulic conductivity values on the dynamics of saline water interface under the injection. Now I will describe the results of experimenting the dynamics of saline water interface under different hydraulic gradients. So these photos showed that the results of the first run, when the hydraulic gradients equal 0.004, so under this gradient, the saline water interface intruded until 99 centimeters in 530 minutes. And then when the hydraulic gradient increased to 0.024, the saline water interface retreated backward direction from 99 centimeters to 11 centimeters, so in 245 minutes. So we supplied around 520 liters of fresh water to clean around 7,210 centimeter cube from saline water. On the third runs, we also decrease the hydraulic gradients to 0.008 to allow the saline water interface to intrude toward freshwater compartments. So the interface reached 97.5 centimeters during 285 minutes. And then when the hydraulic gradient increased to 0.03, the saline water interface retreated backward direction toward saline water boundary and reaches 99.5 centimeters. So during this run, we cleaned around 7,183 centimeter cube from saline water by supplying 500 liter of fresh water. In run 5, the hydraulic gradients equal 0.026, and this allowed the saline water interface to intrude and reach 11.5. And then when the hydraulic gradient increased to 0.06, all saline water flushing out the sand tank in 25 minutes. In addition, the result of the sand tank experiment showed that the retreat rate of saline water interface was higher than the rate of the intrusion for all runs. For example, when the hydraulic gradient equals 0.004, the saline water interface intruded toward freshwater boundaries under average rate around 0.13 centimeter per minute. And then when the hydraulic gradient increased to 0.024, the saline water interface retreated backward direction under average rate around 0.33 centimeter per minute, which is higher than the rate of the intrusion. The result of the second experiment for experimenting the dynamics of saline water interface under the injection well. In this photo, we can see that the location of saline water interface was at the 50 centimeter from saline water boundary. Then we injected around 1.06 liter of fresh water at the top position, and this caused the saline water interface to retreat backward direction from 50 centimeter to 30 centimeter, and we cleaned around 1,172 centimeter cube from saline water. Also, the injection caused a change on the saline water interface shape. The result of a numerical simulation showed that the higher the hydraulic conductivity, we will have more seawater intrusion. Also, when we injected under hydraulic gradients equal, okay, doctor. When we injected under 6.4 centimeter per minute of hydraulic conductivity, the saline water interface intruded from 50 to 31 centimeter, which is at the same location of saline water interface during a sand tank experiment. Then when we injected under higher hydraulic conductivity, the saline water interface only retreated by 2 centimeters. And when we injected under very low permeable aquifer, the saline water interface retreated backward direction for longer distance. So the analysis of the water budget in numerical simulation showed that the injected under low permeable aquifer resulted less discharge of water. Hence, the development of the water mound was high, and this will cause to push the saline water interface backward direction for more distance. So in general, the result of the numerical simulation illustrated that the hydraulic conductivity value is one key factors for MAR to induce significant effect in controlling the seawater intrusion. The conclusion and recommendation. So the main result of our sand tank experiment showed that the retreat rate of saline water interface was higher than the rate of the intrusion. Also, the sand tank experiment illustrated the importance of hydraulic gradients in controlling seawater intrusion. The third point, seawater simulation showed that the low aquifers hydraulic conductivity increases the effectiveness of MAR in controlling the seawater intrusion. Finally, sand tank experiment and numerical modeling should be extended to consider heterogeneous aquifer and other hydrological drivers like the abstraction rate, parameters of tidal fluctuation at sea water boundary. A great acknowledgement goes to Sultan Qaboos University for awarding me a full scholarship for my master study and for the internal grant and the support of the research group. Also, I would like to express my gratitude to the co-authors, Dr. Ali Al-Maktoumi, Prof. Anwar Kazimov, Prof. Athman Abdullah, for their efforts. And I would like to thank Mr. Mohammed Al-Beloushi for the technical support. Thank you for your attention.
Thank you very much, Shahad, for the presentation. So, questions for Shahad, if any?
Thank you, Shahad. Regarding the scale model, here there are some criteria, I think, to conduct the conductivity as a linear time. You didn't include the interfaces between the white ratio because you take the 6 centimeter depth of the sands. And also, if you take the pore and the void ratio inside the stratification of the sand because it is disturbed soil. So if you are going to implement this K, I think you have to go to a pilot study because you have to refer to the water content and the shear limit, wet limit, and plastic limit inside the bulk of the soil column itself because you used the gravitational seepage. You used the injection by the head of the water above the surface of the sand. So I think this is we need because if you are going to this SWOT, you are already included in the numerical modeling or not. Thank you.
Please, doctor, can you repeat? The voice not clear.
أقول لك بالعربي ولا بالإنجليزي بقى؟ حضرتك قول إن البنش سكيل موديل أنت خدتي كتلة من الساند اللي هي عمقها 60 سم. فطبعا الانترفيس هنا لو هتقول ان انا عندي اعمل injection of water via this well to control the seepage from the seawater intrusion هيبقى عندك 4 factors في 3D models لازم تاخديها في الاعتبار عشان تقدري تستخدمي الجرافيتيشنال جريدينتس اللي هو يعمل كاونتر بارت مع الانتروجن السيبج لاين اللي هو جاي من السيرفس بتاع السيوت. وبالتالي الكي اللي هتظهر لك ككوندكتيفيتي هتبقى فيها ايرور لازم تعمل لها كاليبريشن عن طريق بايلوت للناتشورال سويل.
Actually, our sand tank design has control valves in the water compartments. So this valves will help us to maintain constant head at the both boundary of the sand tank that we are using during our experiment. So this control valves will allow us to change the hydraulic gradients during all our runs. So the valves located outside the compartments, away the porous medium of our experiment.
Okay, Shahad, I'm not sure if you really answered the question. And I think it's a very valid point. And I'm sorry just to take this opportunity because I'm part of this research team. So, and she's my student, so I would help to respond. And I think it's a very valid point. And porosity has been measured and it's really a disturbed soil, as you say. But the whole idea here is to understand the phenomena inside the tank and to try to understand what is the response of really of the interface at different intermittent and patterns of recharge to control seawater intrusion, because we do have some case of failure. In fact, when people rush to the site without understanding the phenomena itself, physically how it's happened, apart from the specific or classification of the site. So here is just to develop an understanding of the phenomena and to go to the field. Absolutely, you're right. A lot of detailed specifications and information need to be measured and collected before we start injection.
just in 1 second, we'll save the time for the next speaker. As you are in charge of the study, you have to calibrate this, the delta of the new model going to the new method. So I think
there is a lot of work has been done. I can share with you the full thesis. It's thank you very much. Shahad, I think this is the end of it. Thank you very much for your presentation. And please stay around, maybe if we have some time later on, so the audience can get back to you. Thank you. And now I'd like to move to the next presenter, Dr. Mahad Shmas from Oman, and he will talk about artificial recharge via injection wells for salinity in breast control of Salala Aquifer. Dr. Mahad has his PhD in May 2007 from KTH Sweden, and he is currently assistant professor and chair of civil and environmental engineering department at Aquifer University in Oman, and he published more than 17 papers in international referee journals. Dr. Mahad, the floor is yours for the next 12 minutes, and I will stick to the time as all other speakers did. Please start now. We see your presentation, and also I think we are hearing you. Please.
Okay, thank you very much, Chair. Assalamu alaikum wa rahmatullah. إن شاء الله الصوت واضح.
واضح تفضل.
طبعا مثل ما ذكر الدكتور, I will talk about artificial recharge via injection wells for salinity intrusion control of Salala plain aquifer. We have here in Salala, we depend on this aquifer very well. Long time back, till 2013, only that time we started desalination in 2013. Before that, we depend on this aquifer totally in Salala city. So then because of the high pumping, this saline intrusion occurs. And since I did my PhD, during my PhD, I studied this case, seawater intrusion. One of the management scenarios to control the saline intrusion, it was artificial recharge via injection wells. We have in wells which constructed wells, then we inject the treated wastewater. I will talk, this is the overview, introduction, then the problem, objective, material and methods, results and discussion, conclusion and recommendation. So the problem, as I told you, is increased extraction of groundwater and reduction of flow toward the coastal line or toward the Salala aquifer. Why we have also the reduction? We know that increased extraction of groundwater. The flow we have, the groundwater flow always from the mountain of behind Salala, and we depend a lot on, during the monsoon, the flow always happens. Then 80% of the flow from subsurface flow, we can say, is from the fog water. And I published one paper also about that. Fog water contributes a lot to the subsurface flow from the mountain to Salala aquifer. Since we have the desertification, we lose the trees, so we have less subsurface flow. So then also we have increase of pumping, so then we face the seawater intrusion. So due to the permeable aquifer, we have a permeable aquifer here in Salala. It's unconfined, and it's also shallow from 5 meter depth in the coastal area to about 20 meter depth in the foot of the mountain. So then we have we practice injection scheme here since 2003. The objective is to study the effectiveness of the artificial groundwater recharge by municipal treated effluents on the halting saline intrusion to determine and compare the results of the predictive modeling scenario conducted in 2008 by myself in harmony with the result of the current actual transient scenario for the same period, 2006 and to 2020. While I'm doing my PhD, I published one paper in 2008, and at that time I also I studied the effectiveness of the artificial recharge, and that it was in 2008. And then I predicted the case from 2008, 2006 to 2020. Then now I have the data from 2006 to 2020, so I make a comparison between the actual, scenario, current scenario with the predicted scenario. So I used the 3D flow groundwater modeling for the flow. As solute transport, I used the MT3DMS, and I used the same method during also my PhD. I predicted the simulation for the current actual scenario with the predicted one. As I told you before, the baseline scenario assumes that the underflow is constant. Even we have also the underflow is decreased, but we assume that always the underflow is constant, about 50 million or 51 million meter cube per year, the underflow from the mountain. So here we have the results. Here you can see the water level in 2020. This is the predicted period. And you can see here the zero, the water level here maybe reached about 2 kilometers inland. But when you see 8 kilometers inland here, we'll find 0.5 meter above mean sea level. So that means during the predictive period. But during the actual period, which is, I have the data now, we found that 0.5 meter above mean sea level, it's only reached 4 kilometers inland. And also no intrusion here. You can see the zero, it's not exist. So, with the current situation, it's better to compare the predictive scenario with the current transient scenario. So it was revealed that the results of the water level had increased in the current scenario compared to the predictive scenario during the same period. Also here we can say the comparison has been elicited by means of groundwater pumping reduction from Salalah well field and Garaziz farm. Also here, why there is a reduction also, we have controlled pumping in Garaziz farm and also in Salalah well field. That's the water level here. Here we can see the TDS or the solute transport, and also we can see during the prediction period 300 milligram per liter or 400 milligram per liter. You can see it here, 4 kilometers maybe inland from the coastline. This figure shows that the TDS level reached 3,000 milligram per liter at areas along the injection route line, which is about 1.5 kilometers from the coast. But we will see now the current or the scenario, and you can see it is about 2,000 only at TDS exceeds 3,000 here, whereas it was 4,000 in the other case. This figure shows that the TDS level reached 2,000 milligram at areas along the injection route. It was 3,000, now it is only 2,000 in the current scenario. So the solute transport level shows that the salinity results were decreased in the current transient scenario as compared with the predictive scenario during the same period. The same period is 2006 to 2020. Also, I used the infection transport by PM bath, and you can see here during the predictive scenario, you can see the zero. the injection wells here. Now you can see the injection wells. You can see here the blue, and you can see the intrusion was here about maybe 3 kilometers from the shoreline. This is for the predictive scenario. Whereas during the current scenario, you can see here the intrusion, no intrusion here. So in figure 21, the slow transport of the injected municipal treated effluents could travel almost 500 meters downstream in just 1 year by using PM bath advection transport, compared to the current transient scenario, which is figure 22, which is this one, where the path lines could travel more than 1.2 kilometers. So the injection, will because of the injection, the path lines with the travelage more than 1 kilometer downstream from the injection lines in about 1 year. So this means that it's better in this current situation, better than the predictive situation. Conclusion and recommendation: the injection scheme of the municipal treated waste treated effluents in Salalah Aquifer stabilize the water level and reduces the TDS salinity along the injection lines. The abstraction from the aquifer has been able to manage abstraction have been managed 77% of the pumping rate of the wells that operating in Garziz Farm considerably blocked since 2012, because we have about 13 wells. They blocked about 10 in 2012. So then we reduced the abstraction. The abstraction from Salalah well field also, for Salalah well field is used for water supply to the city. I told you that we depend on Salalah well field before 2013. So it was reduced by more than 60%, the pumping from this aquifer. In 2020, as the reverse osmosis technology facility started to operate concurrently, producing 25 million meter cube per year of water since 2013. Unfortunately, because we cannot control our aquifer, it has more, so saline intrusion occurs, then the flow also, groundwater flow decreased. So we started using, or establishing reverse osmosis, and only in Salalah in 2013 we started, using the reverse osmosis water. Before that, we used the Salalah aquifer, the water from Salalah aquifer. It has been found that the direct injection method conducted along the eastern and western edges of the Salalah aquifer was found less successful as compared to the injection procedure conducted in the middle of the injection borehole of the aquifer, because of hydraulic conductivity is less in the east and west part of the aquifer. Those manifestations were attributed to the slow movement of underflow recharge in the edge of the aquifer, along with the fast movement of saline intrusion. The slow transport also shows that the TDS result decreased in the current transient scenario as compared with the predictive scenario during the same period. This is the last slide. There was weak subsurface flow, as I already explained to you, weak subsurface flow, because we have the desertification, and we depend a lot on fog water collection or fog water recharge. This study recommends allocating the rate of injection in the middle of the injection borehole. Instead of we have 40 injection wells, 10 in the east part of the aquifer, 10 in the west part. So we have to close this 20 in the east and west part, and we have to concentrate the quantities of this water in the middle of the injection borehole. Since 2012, 10 wells were closed in Garziz Farm, which means only 3 wells remain pumping groundwater at almost 2.26 million for cultivation of rhodes grass, compared to pumping was 8 million meter cube. And myself, in my PhD study, I recommend that to relocate these farms, or at least to decrease the quantities pumping from this farm. And that's good. Now we are pumping only about 2 million instead of 8 million before 2012. This is a big farm using cultivating rhodes grass. The implication that 77 of the pumping rates were blocked from 2012 to the present with different. Yeah, I'm just finishing. How many minutes I have? I still have? That's it?
Please try to make it up very fast. Thank you.
No, that's finished. The expansion of STB also took place. We have the expansion of STB and reached now currently about 50,000 effluents to a tertiary level. But unfortunately, of which only 40% of municipal treated effluents output were used in 2020 for artificial recharge or for the injection. This study recommends reusing more than 80% of the municipal treated effluents into the injection boreholes. This process can be considered as an effective integrated water resource management method for Salalah coastal aquifer. Thank you very much.
Thank you very much, Dr. Mahad. The floor is open for questions now. Okay, I will start with Engineer Ahmed, and then please make it short question, and the answer should be brief, Dr. Mahad, and then we'll go to Muhammad Al-Rashid.
I have two very short questions.
Make them start with one, please, just for the time. So,
okay. Did you consider the recharge from? We know that there have been a lot of cyclones in Salalah, and the Kharif for the past few years was very good. Did you consider that in your calculations of your model?
Dr. Mahad?
Yeah, I heard him. Yeah. You know, during my PhD study, I considered all this water level because of, as you said, during the cyclones, water level will rise and so on. We'll have water level record or data from water resources ministry here or department, and we can use it, include it in the model. But in this study, I used, the constructed model. I have already constructed this model since I told you, since my PhD in 2006 and so on. So I just used the same model, and I changed the pumping, how much is pumping from the farm, how much pumping from the Salalah well field. I mean, also the injection from the wastewater quantities, and I assumed that the water level is just constant.
Thank you, Dr. Mahad. The second question from Dr. Muhammad Al-Rashid.
You mentioned in the recommendation that you are recommending using more tertiary treated wastewater for injection. This might affect groundwater quality because in Kuwait we are using advanced water RO filtration wastewater treated, and in addition to that we also treat the water before injecting into the groundwater. So there is a dangerous to pollute the groundwater around the study area. This is my comment on that.
Question. Okay, doctor. I published another paper about this in 2008, and even here you can see the pumping. Let me see. Here you can see the injection wells. Injection wells is about 1.1 kilometer, you can say, from the coastline. About 1 kilometer, 1.5 kilometer from the coastline. And this area is already saline. It has a saline intrusion. I mean, we refused to inject it at Garziz Farm. I mean, I was in the Ministry of Environment before I joined Dhofar University. You can see here Garziz Farm. It's about more than 5 kilometers from the coastline. We refuse to inject the treated wastewater there, but we allowed the injection here. So the injection boreholes are here. Along you can see it in the picture. So it's about 1 kilometer, and it's already saline, and it's already brackish water. So it, I mean, from the quality point of view, I haven't studied it, but I mean, we assume since it's brackish and it's already saline, it will not. I mean, TDS also increases. I mean, better reduces the TDS with the injection. TDS decreased. But as you said, from the quality point of view, so we haven't read. I mean, I haven't studied this.
Thank you, Dr. Mahad, very much, and thank the audience for the questions. And I think it's the time to go for the next speaker. Dr. Mahad, thank you very much again. So
Doctor, I would like to thank Dr. Walid Al-Zubari. He is one of my advisors during the PhD study, and he himself, you know, taught me how to use the modeling. And thank you very much for him. I sent him a message from Salala, thankful message.
Thank you very much.
I know he is around there.
He is around. He is listening. He has ears everywhere. Thank you. So let's welcome our next speaker. We have Shidam Bram Sabra. I'm sorry if I pronounce your name not properly, from Kuwait, and he will present a talk about equilibrium states of groundwater chemistry in coastal region of Kuwait. And unfortunately, we don't have a lot of information to introduce you properly. So sorry, we just received one line. So you can say a few words about yourself. What I'm having here is that you are working for the Water Research Center in Kuwait Institute for Scientific Research in Kuwait. Doctor, the floor is yours for the next 12 minutes, but you can say a few words about yourself for the audience, and we are so sorry about that because we haven't received enough information like a short bio to introduce you properly. Please.
Thank you, Doctor, and good afternoon to you all. I hope I am audible and my screen is visible. I'm audible, Doctor? Am I audible? Doctor, I think I'm audible.
Sorry?
Am I audible?
Yes, please.
Yes. Yeah, thank you, and thank you for the opportunity. And I would like to first thank the organizers for giving us this opportunity to share some of the views on this topic. But before going into the topic, a small line of introduction. I am Dr. Chidambaram. I am working here in Water Resource Development Management Program in WRC at Kisar. Earlier, I was working as a professor in a university in India. I had been working on the field of hydrogeochemistry since past 22 years. So that is a short line of introduction, and I'll just go into the topic of the day. This is on the equilibrium states of groundwater chemistry in the coastal region of Kuwait. It's like a kind of an experimental kind of a study, and we just wanted to know what would be the condition, like we just wanted to model geochemically what would be the case. And I will go into it in more detail, and the presentation I have structured it this way, like on introduction and something on the study area and methodology, results, discussion and conclusion, and then on the acknowledgement. So as such, we have the brackish to saline groundwaters, which are most common in the arid regions, and we have also reported saline to acidic hypersaline groundwaters on the region. But to be on this condition, we just wanted to know, like, whether when there is no interference of an anthropogenic process or when there is no seawater intrusion, will there be a change on the geochemical composition of the groundwaters, even with a small change in the temperature or pressure, or just with the natural temperature changes, will there be a change in the geochemistry of the region, and whether that will have an impact on the groundwaters or the utility of the groundwater. So for that, we have attempted this study to identify whether there will be a change in the thermodynamic states of the groundwaters of the region. As you know that there had been incrustations on pipes during the travel, or from the groundwater when it is being extracted from the ground, or when it is delivered onto the surface. Between the travel time, there had been precipitations on the walls of the pipes, as the picture shows here. You can see the incrustations. And on the surface also, we have the oxidations taking place without much of change. And similarly, when an aquifer is connected to it's a ferritic aquifer, or when it is when it is unconfined aquifer, when you have an atmospheric interaction, so that when there is a change in the temperature, whether you will have a saturation, or whether you will have a precipitation on the pore spaces within the aquifer itself. So that kindled this kind of a study, and we just wanted to know what will happen if there is a variation in temperature from, like, say, 4 degrees to about 45 degrees in a region. So our study area of Kuwait, it was a very apt kind of a region, like where we had a drastic change in climatic conditions with respect to different seasons. Like from 4 degrees, we had up to about 45 degrees kind of a drastic variation in temperatures. And in this condition, we had a different lithologies, we had anthropogenic activities also. So currently we just had a basic background about the current situation. And then if at all, if there is a variation in temperature alone, what could be the condition? So that is the main crux, or the main objective of the study, which is being focused today. So here I just wanted to introduce you to the area where we know that it's a Transpondery aquifer, and we have 2 basic aquifers here, which is being utilized in Kuwait, where the lower aquifer is the Dammam formation and the upper one is the Kuwait group aquifer. And our study pertains only to the upper part of the upper aquifer alone, which is the Kuwait group aquifer, where it forms the mainly chiefly composed about sand, silt, and clay. It's a mixture of some calcareous sand also, but on the Dammam, it is mainly of limestone. So we, because we are talking about the change in temperature and temperature alone, we just wanted to consider the ferritic aquifer, that is the unconfined aquifer. So our study pertains only to the Kuwait group aquifer. So wherein 20 shallow boreholes were selected, less than 60 meters below ground level, and most of the cations, anions were analyzed with the trace metals. So after the analysis, we tried to plot the stability conditions. We just wanted to know the current conditions with respect to silicate minerals and with respect to the carbonate minerals which are present in the aquifers. And then that was done with the help of the software which was developed in WRC Kisar itself. And that is the software, it's on Chidam. It is available on the Groundwater Sustainable Development Journal. You can download it for free and you can use it. And then with respect to the temperature variation, we try to use the frequency software, wherein we modeled from 19 degrees to 28 degrees, which is the normal variation in temperature which we have observed in the groundwaters of Kuwait. And during the course of modeling, we studied the saturation states, the variation in pH, ionic strength, and the groundwater composition with respect to each temperature variation. So that being the case, I'll just give you a result overview of the result. And these are some of the sampling locations where we collected the samples along the coast, and a few samples were around the Bay region, and a few samples were on the open sea region, adjacent to the open sea region. And here we have the maximum minimum average values of these samples which were collected. And you can see there is a maximum value of about 97,840 EC was also reported, like hypersaline conditions were also reported here. And correspondingly with respect to sodium and other major cations. Then coming to the part of the thermodynamics, like actually the current composition was plotted with respect to 2 stability plots, which were one with respect to silicates and the other with respect to the carbonates. And this is with respect to the silicate stability plot, which is very commonly used when to study this thermodynamic nature of the groundwater. So wherein what we consider is generally when the composition falls in this field. This is with respect to different ions. First, I'll introduce you to the plot. So wherein here it is calcium based, this is potassium based, and this is magnesium based. So we consider the minerals based upon calcium on this plot and based upon potassium on this plot, and similarly for the magnesium. So this is basically between silica and the other ions. So it is considered as silicate stability plot. So when it starts weathering first, the initial, when the water enters into the aquifer, the initial composition will be stable with respect to gibbsite. Then the composition moves towards kaolinite. Then it comes to the montmorillonite, the clay, the ultimate product of weathering. So wherein what the migration takes place from the gibbsite to that of the montmorillonite. So even here, it starts from gibbsite. Either it travels through this path or it travels through this path. It depends upon the pressure, temperature conditions. And similarly here, the first stage of weathering, it starts with gibbsite, then it moves here. But in all the cases, most of the samples were stable with respect to the kaolinite field. It means that the water had entered into the system and it has been there for some time, and some reaction has taken place with more silicate being acquired from the aquifer itself. So that is what we infer from this picture. And then when we move to the another diagram, which correlates with respect to that of the what do you call the feldspar, different family of feldspars, wherein we start from the albite to anorthite fields, which is means like calcium rich, and to that of the sodium rich. So the samples almost fall from that of the albite to that of the kaolinite field, means from the mineral composition, it migrates to that of the clay composition. So means weathering has started, and there is stability of minerals from on normal mineral composition to that of the clay composition, which you can observe here. When the complete weathering has taken place, the entire composition will be moving from here to that of the kaolinite stage. But still, it's moving towards the direction of complete weathering. So the next part is that with respect to carbonates, wherein you can see that most of the, this is general trend, which is indicated with the into marks. And these plots, they indicate the composition of the samples. And this one indicates the seawater. So this is the seawater composition, and these are all the groundwaters which are collected from the current study. So most of the samples are with respect to magnesium rich carbonates, that is dolomites. They are stable with that. So this is the current condition. So now when we try to model, we try to model with respect to the temperature, as I have told you, from 19 degrees to that of the 28 degrees. So just a 10-degree variation of temperature, we just wanted to model. And here, before going into the table which is given here, I'll just give you what are all the minerals which I have considered for modeling. So with respect to sulfate minerals, I have considered anhydrite and gypsum. And with respect to carbonate minerals, aragonite, calcite, dolomite, and magnesite was considered. And similarly, halite, the sodium chloride mineral, was considered. And with respect to silica, different forms of silica was considered, like that of quartz, amorphous silica, and chalcedony. And silicate minerals like that of clinoenstatite and forstatite were considered. So these were all considered based upon the composition of the aquifer itself. So there are mineral occurrences of few magnesium silicates and iron silicates which were reported in the earlier studies. So considering the composition of the aquifer, all these minerals were considered for the saturation index studies. So what happened was, when we calculated the saturation index, the highest saturation index was with respect to the dolomite. And then, I'll make it fast. So this is the order of saturation index which we got for different elements. And here it indicates, this table indicates that when there is an increase in temperature, there is an increase in saturation index of all these minerals, means there is a possibility of precipitation of these minerals onto the pore spaces or during the travel. And it's very interesting to note that anhydrite is temperature sensitive, means there is a change in the saturation states with respect to temperature. So you can model or you can make anhydrite to precipitate when there is a change, when you change the temperature. So that is one important significance of that. And then there is another important observation where you can say there is a common ion effect which plays an important role, where calcium is being shared with the carbonate and sulfate as anhydrites, or that of calcite or dolomite. And magnesium is also shared with sulfate or bicarbonate. So there is the sharing of ions between the formation of minerals. And during this case, when there is an increase in saturation index of carbonates, there is a decrease in saturation index of sulfate, or the vice versa takes place. So means calcium affects the formation of the either anhydrite or that of bicarbonates. And this is again governed by the pressure, temperature, and concentration of the ions which is present. And now here, this is the spatial distribution of the saturation index. So we can see that there is a, along the distribution pattern, we can see that the saturation index of anhydrite and saturation index of magnesite are lesser, means undersaturated in these regions around the bay, but it is saturated in the regions here. So means that there is a process which governs the saturation index of these magnesite and anhydrite, that is sulfate. So presence of hydrogen sulfate in these regions have influenced the formation of these two minerals. So coming to the conclusion part of it, so the temperature variation shows an increase in saturation index and the decrease in saturation index for certain elements, and pH governs the saturation index of magnesium, magnesium-based minerals, and there is a lower saturation index based upon around 21 degrees to 24 degrees. There is a common ion effect observed between the formation of carbonate minerals and that of sulfate minerals. And the more saturated, the open sea is more saturated than that of samples of bay. And this study will be very useful when the water is being transferred from the pumping region to that of the sharing location, and even the normal precipitations like formation of gas layer or formation of precipitate on the surface on the capillary zone itself will be can be studied with the help of the modeling. And thank you for the opportunity given. I would like to thank the WRC management and the KISAR management for giving me an opportunity to present the finding. And I would also like to thank the coordinators and the chair for giving me enough time for the presentation of the results. And thank you very much.
Thank you very much. Indeed, a very interesting presentation for a very interesting topic, which is MAR and ASR, which is a growing topic now of concern in the region. So I would like to open the floor for a few questions. Basically, 2 questions, if any. Can you check if it is online? Maybe in the audience online they have some questions. So if there is no further questions, we'd like to thank you very much for this nice presentation, Dr. Sabra Finan.
Thank you. Thank you
for being with us today. And I think maybe if I was expecting to see some questions online from the audience, that's why we kept the presenters with us till the end of the sessions, but I think there is no questions. And we're supposed to have a last presentation for today, but unfortunately we are not hearing from Dr. Khalid Rashid from Qatar, who's supposed to give a presentation about rainstorm harvesting technologies in Qatar, but we are not, he is not here, right?
السلام عليكم. موجود
دكتور
خالد؟ اي معلش اسمح لي، انا دخلت ممكن في الغرف الخطا وطلبت اللينك الصحيح والان ارسلوا لي اياه.
اوكي.
عذرا اذا تاخرت شوي عليكم، لكن انا اوعدكم راح تكون سريعه ان شاء الله البرزنتيشن. اعرف ان الوقت شوي تاخر.
Okay, so then I would like to make 2 points here because of the time. So I would like to ask you to introduce yourself because we don't have any information about you. We haven't received any short bio for yourself. So please, you have the next 12 minutes to present. We are having a short time. I would appreciate if you can have it shorter than that.
Inshallah.
Sorry?
It will be short, inshallah.
It will be short. Because myself as a chair, I will be replaced by someone else for the next, for the last session because I have to leave for my flight. So please introduce yourself and then start your presentation.
نعم. أخوك خالد علي رشيد، رئيس قسم الآبار والمياه الجوفية في المؤسسة العامة القطرية للكهرباء والماء من قطر. عندي الورقة البحثية بخصوص تقنية آبار حصاد الأمطار. خليني أعمل شيرنج بس لو سمحت.
Can you share your presentation from your end?
I am trying, but I 1 minute. Can you see it? واضح؟
Yes. Can you make it display?
عفوا الصوت مش واضح الشيخ، الصوت بعيد جدا. السكرين واضحة عندكم؟
سكرين واضحة لكن مش في الديسبلاي مود.
عفوا في البيبر عنوانها Promoting Rain Water Harvesting.
اعتقد انت تعرض للجهاز مربوط بشاشتين. Okay. Can you put it now in the display?
في عفوا دقيقة الشيخ. I'll try again. And when I click and share, because I never use Zoom to be honest, all Microsoft Teams. بس لما أضغط على share يعطيني خيارات basic advanced files. I don't see desktop to share it.
ما مشكلة. روح على البيسكس.
اوكي بيسك.
ديسكتوب او شير سكرين تمام. اوكي
سكرين
سلايد شو بقى، اضغط على سلايد شو خلاص كده تمام. كبر الشاشه
باينه ولا؟
سلايد شو
عفوا الصوت مش واضح. باين السلايد؟
اضغط كبر الشاشه.
الصوت بعيد اخوان ما اسمع. هل واضح
واضح يا دكتور؟ تفضل.
واضح.
بعد ما تخلص الجلسه هذه خليكم اثنين راح يكون لكم
واضحه. ممكن ابدا؟
في هذه القاعه.
تمام تفضل دكتور.
تفضل.
نعم. الورقه البحثيه انا باختصار بس على اساس الوقت معذره مره ثانيه، هي بخصوص تقنيه ابار حصاد الامطار والريتشارج في الحوض الجوفي. طبعا قطر ما فيها مصادر مياه السطحيه مثل البحيرات وانهار. المصدر الوحيد المتجدد هو المياه الجوفيه، والتغذيه الاساسيه هي من مياه الامطار. عاده الميزان المائي يبين ان غالبيه المياه الجوفيه تستخرج وتستخدم من قبل المزارع، اكثر من 70% من المياه الجوفيه، والكميه المستخدمه عاده 4 أضعاف كميه المياه اللي محصوده من الامطار. طبعا كهرماء المؤسسه العامه القطريه للكهرباء والماء قررت ان تعمل اعاده تاهيل ل 300 بير حصاد امطار موجودين اصلا، اكثر من 300 بير، وتاهيل 70 بير جديد في مشاريع قائمه بها المؤسسه. أهمية حقن المياه الجوفية: زيادة الميزان المائي، تحسين نوعية المياه في الخزان الجوفي، استخدام الخزان الجوفي للتخزين في المواسم المختلفة طبعا، ومن أهمها أيضا منع تداخل المياه المالحة عن طريق حواجز المياه العذبة، وتقليل منع الفيضانات. عندنا الآن هذه آلية تطوير بير الحصاد المائي. طبعا البير يتم عن طريق حفر 70 إلى 80 متر. هذه واحدة من المشاريع اللي احنا عملناها، وفيه تنظيف حوالين منطقة البئر، وبعدين في تثبيت للستيل بايب اللي هو قطره 8 إنش، وهنا في تثبيت للمنطقة اللي حوالين عنق البئر، وتثبيت الحواجز اللي راح يتثبت عليها الستيل مش، والبايب نفسه البرفوريتد بايب الستيل هذا يحمى ايضا بمش على اساس ان الاحجار الصغيره ما تدخل في عنق البئر خلال موسم حصاد الامطار وجريان المياه. هذه صوره البير طبعا بعد اكتماله. احنا نستخدم الجابرو. هذه الصوره ممكن تبين لايمستون، لكن هذه كانت تجربه. اما الحجر المستخدم هو الجابرو، وفي النهايه يلف البير بجيوتكسايل ممبرين على اساس يمنع الطين من السقوط في البير، وينقي المياه الجاريه قبل ما تدخل في البير نفسه. وهذه الصوره النهائيه للبير. فيها بحدود 10 أو 15 سنتي من القابرو حوالين البير بارتفاع معين، والباقي كلها حوالين عنق البير. الآن احنا يعني الكيس ستدي اللي عملناها كانت في حقل مياه اسمه حقل مياه أبو ثيلة. كانت المشكلة أن عندنا الأبنية والمعدات اللي موجودة في الحقل تتأثر بالمياه اللي جاية من الأمطار، وكانت تسبب فيضانات وتأثر على هالأبنية والمعدات. فقررنا أن احنا نأهل أو نطور 10 آبار رين هارفستنج ويل داخل هذا الحقل. الصورة هنا تبين الصورتين. أول نزول المطر مباشرة احنا كنا ماخذين الصور، وقبل طبعا ما كان في آبار حصاد كانت تقعد يمكن أسبوع أو أسبوعين ما في أحد يقدر يدخل المحطة، وكانت تسبب لنا مشاكل بالنسبة للمعدات وبالنسبة للأبنية اللي موجودة. الآن بعد ما طورنا ال10 آبار احنا نشوف هنا المياه مباشرة خلال يوم أو يومين بالكثير تنزل مباشرة في الحوض الجوفي. وهنا ما أدري إذا واضحة الصورة ولا لا، حجم التغذية الترم شيت أو الجيوتكسايل ممبرين، اللون الأبيض هذا هنا الفاصل بين الأبيض والبني هو المستوى اللي وصل له الماء. واضح أن الماء كان بحدود 1.5 متر. ففي السنوات الماضية قبل تأهيل الآبار هذه كانت المياه ارتفاع 1.5 متر تكون موجودة وتمنع دخول أي شخص للحقل، وكانت تأخذ فترة طويلة على ما تنزل. الآن مباشرة مثل ما ذكرنا في يوم واحد يعني ينزل الماء ونحصده. والجدول هنا يبين في الجهة اليمنى ال10 آبار كلها المستوى التحسين في مستوى المياه الجوفية في كل بير. يعني عندنا بحدود 1 متر إلى 1.23 متر أعتقد أقصى حاجة احنا قرأناها. ارتفع فيها طبعا الميزان هنا. وهذه جراف ثاني، طبعا التجربة كانت في 2018 تبين أيضا مستوى المياه. والصورة هذه بعد فترة نزول الأمطار بكم أسبوع، باين طبعا فيها انتعاش الحياة الفطرية والنباتية حول الآبار هذه. في كل المناطق اللي احنا عندنا آبار حصاد مائي لاحظنا هذه الظاهرة، انتعاش الحياة الفطرية والنباتية بشكل كبير. طبعا احنا من التجربة هذه يعني we draw conclusion أن لازم نزيد من عدد آبار الحصاد المائي في أغلب المناطق اللي مؤهلة حسب طبعا الخرائط اللي عندنا وحسب الدراسات اللي موجودة، بسبب نتائجها اللي كانت واضحة لنا، ومن ضمنها ارتفاع المستوى في الووتر ليفل في الأكوفر بحدود 1.5 متر على حسب المنطقة طبعا، ومثل ما قلنا انعاش الحياة النباتية والفطرية حول الآبار وزيادة المخزون الجوفي. شكرا. طبعا أنا أعتذر مرة ثانية إني تأخرت عليكم في العرض، أتمنى أن ما أخذت وقت كثير.
شكرا لك أستاذ خالد على العرض الجيد. Thank you very much for the nice presentation. I think this is the last present speaker.
Yes. شكرا. جزاك الله خير.
If there is any question, Dr. محمد الراشد. This is your.
يعطيك العافية خالد. بس في استفسار بالنسبة لما شفت مستوى المياه الجوفية ما في تغيير كبير عليها، يعني كان ثابت تقريبا. فسؤالي
شوي نعم
الفترة اللي تقريبا صارت 2 أو 3 في الموضوع. الشغلة الثانية، هل هناك تغير في تحسين نوعية المياه الجوفية في المنطقة؟ يعني هل لاحظت الشيء هذا؟ شكرا. شكرا دكتور.
نعم ما في شك. احنا عندنا طبعا المختبر في المؤسسة يشتغل معنا ايد واحدة يعني في الموضوع هذا، ودائما عندنا بروجرام ان ناخذ العينات من الآبار هذه، والنتائج بينت ان في تحسين ما في شك في نوعية وكمية المياه الجوفية اللي احنا يعني حصدناها من الأمطار. وبالنسبه للمستوى، انت لما تشوف مستوى 1.5 متر، انا اتكلم عن قطر طبعا اللي ما عندنا اي مصدر طبيعي للمياه غير الامطار، فالمتر ونص هذه على مسطح كبير، حوض جوفي كبير، يعتبر كميه يعني معتبره، او خلينا نقول كبدايه يعني. لهذا السبب احنا الان في طور ان نطور خلال مشاريع جديده ابار كثيره للحصاد المائي. هو الدراسه من الاصل كانت من يعني الاستشاري ومن الخبراء اللي عندنا، لما طوروا، لما اسسوا ال 300 بير هذه، ان المفروض تكون في قطر 1500 بحدود 1560 بير. فالان احنا لازلنا في طور يعني اقل من 400 بير حصاد. احنا نتامل بعد ما نخلص او نوصل لهذا الرقم خلال السنوات القادمه انه يكون في تغيير وارتفاع اكثر من المتر او متر ونص اللي تكلمنا عليه باذن الله.
Question. Is there any question? Last question. Okay. Thank you very much for the speakers. Thank you for your attendance. Now we will announce the recommendations with Dr. Al-Zubari.
بسم الله الرحمن الرحيم. نبدأ الآن الجلسة الختامية. وطبعا المؤتمر 14 للمياه ما شاء الله حضر زملاء وباحثين كثيرين في كل المجالات، في كل المحاور اللي طرحت في المؤتمر. طبعا مثل ما تعرفون انه بدأنا الأحد الصباح بتشريف معالي الوزير، كان حفل الافتتاح طبعا من تقريبا الساعة 9 قريب 10، بعدين افتتاح معالي المعرض، ثم عملنا جلسة مهمة جدا عن اقتصاديات أموال المياه، وأيضا 3 ورش عمل مميزة جدا. وأمس أيضا كان عندنا جلسات الحمد لله جيدة جدا في التحلية وفي القطاع الزراعي، استخدامات المياه في القطاع الزراعي، وأيضا كان فيه عن الصرف الصحي، معالجة والاستخدام، إعادة الاستخدام. ثم اليوم ختمناها بجلسات عن المياه السطحية والجوفية، وعن أيضا استخدامات المياه البلدية، وأيضا الهيدرو انفورماتكس. طبعا نأمل إن شاء الله أنه نلقى بعض الزملاء الموجودين وغيرهم في المؤتمرات القادمة بإذن الله. طبعا الجمعية أولا اسم الجمعية واسم زملائي أعضاء مجلس الإدارة أشكركم جميعا على الحضور وعلى المشاركة في جلسات المؤتمر والنقاشات، وأتمنى من الله سبحانه وتعالى أن يوفق الجميع. طبعا الجمعية حريصة على استمرار الاتصال بالزملاء في جميع الدول العربية، وبالطبع احنا إن شاء الله مجلس الإدارة سيقرر بعد فترة وين إن شاء الله يكون مؤتمر الخليج 15 للمياه. مرة أخرى أشكركم جميعا على المساهمة وعلى الحضور والمشاركة، وأتمنى الزملاء جميعا عودا حميدا إلى أوطانهم، ونريد التواصل منكم مع الجمعية والمساهمة في أي عمل تعاوني ترونه يكون مناسب مع مؤسساتكم في بلدكم وبين الجمعية. الآن أنا أعطي الميكروفون لنائب رئيس الجمعية ورئيس اللجنة العلمية الدكتور وليد الزباري لكي يعطيكم نبذة عن ما جمعناه من توصيات مهمة. تفضل يا دكتور.
شكرا. طبعا بنعطيكم نبذة عن التوصيات محورها، لكن راح يتم ارسالها للجميع في حدود اسبوع 10 ايام، وبعدين راح ترجع للتعديلات. So we will be giving this in both Arabic and English language, the recommendations. We will send it to all the conference participants, and they have probably 1 week to put their input or correct or amend or delete or modify, and then we will be making the final conclusion recommendation of the conference, and then we will send this to the Secretariat General of the GCC, and it will take it in turn and will give it to the Minister of Water Resources as our input to the water sector in terms of recommendation. I'm going to now switch into Arabic. Okay. تم عقد عدد من الجلسات على مدى 3 أيام، وكانت الجلسة الأولى عن اقتصاديات المياه والتمويل، وأهم التوصيات اللي طلعت من هذه الجلسة بشكل عام وليس ما كتبناها لم نصلها الآن، أن هناك ضرورة تكملة النهج المتبع حاليا بشكل كبير لإدارة الأرض وتعظيم الموارد المائية وتعظيم المتاح منها إلى نهج إدارة الطلب والكفاءة والترشيد، وبالتالي احنا محتاجين إلى أدوات، والأدوات هذه ستكون أهم الأدوات التي لدينا هي الأدوات الاقتصادية، هي التي ممكن أن تؤدي إلى زيادة الكفاءة والاستدامة المالية. وتم مناقشة الوسائل المطلوبة، وكما تذكرون سليم الذكري تكلم عن أنواع الأدوات الاقتصادية المطلوب عملها، وراح نتفق طبعا بشكل بسيط ولا نركز على أحد منها، ولكن يجب استخدام الأمثل اللي على حسب وضع الدول. طرح أيضا موضوع زيادة مشاركة القطاع الخاص وإعطاء الفرصة للمساهمة في بناء أو تشغيل القطاع المائي لتقليل تكاليف الدول، وأيضا لتطوير نظام المحاسبة الموجود عندنا، بحيث أن أنت عندك جهة ممكن محاسبتها، فحكومة ما تحاسب حكومة، لكن الحكومة ممكن تحاسب قطاعات. هذا أيضا طرح في إحدى الجلسات أنه ضرورة مشاركة القطاع الخاص. بعد ذلك طرح طبعا مشاركة القطاع الخاص أساسا للتمويل أكثر منها جانب اقتصادي. الجانب الثاني اللي هو طرحت ايضا قضيه التغير المناخي، جلسه خاصه عن التغير المناخي، تغير المناخ بالنسبه حق الناس اللي كانوا موجودين انه هو المنطقه ستتاثر بتغير المناخ، هذا هو الفاينل كونكلوجن، ان احنا climate change will impact our resources، ما في stationarity anymore، راح يكون الامور ليست كما الهيدرولوجيكال داتا اللي اخذناها سابقا ما لها معنى الان لانها راح تتغير، فما نقدر نعتمد عليها في الديزاين. سوري تو سي ذس فور يو سيرفيس ووتر، ما تقدر تعتمد على الديزاين، فلازم ناخذ في الاعتبار كل الاشياء اللي صارت، ويجب الاعتماد على النماذج الرياضيه الحديثه. كل النماذج الرياضيه الان متفقه على ارتفاع درجه الحراره، وقد تكون هناك في زياده الامطار في بعض المناطق، ولكن زياده الامطار هذه ايضا مور انتنس رين، تاثيراتها راح تكون ديستراكتيف اكثر منها انها تكون هذه، وهذه يجب ان ناخذها في الاعتبار. هذه التوصيه اللي طلعت من الجلسات تغير المناخ، وضروره ادماج التاثيرات هذه في الاداره المتكامله للموارد المائيه على المستوى الوطني وممكن حتى المستوى الاقليمي. بالنسبه حق المياه التقليديه ايضا الجلسه الاخيره اللي صارت قصيره جدا، ان هي يجب النظر الى المياه التقليديه والاستثمار فيها بشكل كبير، لان هي الملجأ الوحيد الان صار لنا. مياه الصرف الصحي المعالجه ومياه التحليه هي الملجأ الوحيد، لا توجد عندنا امطار ما عندنا تغذيه المياه الجوفيه، ما عندنا مياه جوفيه بشكل متجدد بشكل كبير، والمياه في مواجهه الطلب يجب التوجه لها، وبالتالي انت محتاج الى تستثمر فيها بشكل كبير. طبعا التحليه والصرف الصحي في له جلسات خاصه صار في تفصيل بالنسبه ماذا يجب عمله لاستدامتهم، وراح اتكلم عنها بعد شوي. في التحليه طبعا الدكتور ابراهيم كان هو المتميز في هذا الموضوع، انه يجب وضع مؤشرات لاستدامه التحليه في الموضوع، ويجب ان تكون على المستوى الاقليمي، ويجب طبعا الاستثمار. طبعا كعمليه الاستثمار في البحث والتطوير كروس كاتنج كل شيء، ما في داعي نقول كل مره ان احنا يجب ان نبحث او نستثمر، فيجب على مراكز البحوث والوزارات ان تستثمر في البحث والتطوير في كل القضايا وليس قضيه التحليه، ولكن التحليه شيء اساسي ويجب الاستثمار في تلقين هذه التقنيات. تم طرح الطاقات المتجدده واستخدامها في التحليه، وانتم عارفين صعوبه الامر يعني بالنسبه لنا كدول نفطيه ننتقل الى التحليه، ولكن هناك في يعني محتاجين ان احنا شوي نقنع صاحب القرار انه هو التوجه نحو الطاقات المتجدده ليس فقط لتقليل الخارجيات او التاثيرات البيئيه حوالين التحليه، ولكن ايضا لاضافه الامر المخزون النفطي اللي يعني ايضا هذا يعني في قيمه مضافه في هذا المجال. ان شاء الله. الزراعه يعني الزراعه والمياه الجوفيه لم تخرج عن المعتاد، ما زلنا نراوح في اماكننا. رفع كفاءة الري يعني ما زلنا نتكلم عن كفاءة ري جدا منخفضة، ويجب وكفاءة الري يجب ان هذه باستخدام التقنيات الحديثة، تقنيات الزراعة الحديثة، تقنيات الري الحديثة، يعني مش فقط التوجه الى التنقيط انما يمكن التوجه الى الهيدروبونكس كزراعة حديثة وليس ري حديث. طبعا تداخلت، وهذا يدل على اهميه هذه المياه، تداخلت مياه الصرف الصحي بشكل كبير في جلسه المياه الصرف الزراعي في المياه الزراعيه، وصار النقاش كله على الصرف الزراعي على الصرف الصحي بدل ما يكون زراعه، ولكن هناك يعني وش ان احنا مياه الصرف الصحي هي يجب ان توظف في القطاع الزراعي لتقليل الضغوطات على المياه الجوفيه والمياه السطحيه. هناك في طرح لوضع حوافز المزارعين لتبني انظمه الري الحديثه، اوكي، والمشاركه المزارعين ايضا كوبريتيفز وجمعيات نتعاون معهم. يجب ان نوعي المزارعين بالصرف الصحي والاستخدام الامثل له، ويجب ان نضع ايضا قوانين والمراقبه في الزراعه. فهذه كانت بالنسبه للزراعه. اتمنى انه يكون يعني في عندنا اضافات اكثر لما ارسل لكم هذا الشيء. بالنسبه حق الصرف الصحي طبعا النقاش دار حوالين ما هو الاستخدام الامثل للمياه الصرف الصحي، هل نستخدمها في الصناعه ولا نستخدمها في التبريد ولا نستخدمها في غسل الرمال ولا نستخدمها في الري الغير منتج ولا نستخدمها الري المنتج. كل الامور دي محتاجه الى نقاش، ولكن كل دوله يجب ان تنظر او كل موقع اصلا يجب ان ينظر الى الاحتياجات للمياه الصرف الصحي. انا اعرف مثلا في وادي حام في الامارات يستخدمون اكثر شيء المياه الصرف الصحي في الصناعه وليس في الزراعه، يستخدمونها في الكسارات مثل الرمل، فهنا القيمه المضافه لها عاليه ولما لا. بالنسبه توصيه جدا مهمه يمكن يعني حبينا نبرزها بشكل جيد، ان هناك في مخاطر من خلط المياه الصحيه، مياه المستشفيات والمستوصفات وغيرها مع المياه الصرف الصحي العاديه، وهذه يجب النظر لها بعين الاعتبار بشكل هادي. هناك طبعا ايضا في نقص في البحوث في هذا الاتجاه، عندنا بحثين بس في هذا الاتجاه، لكن الهرمونز والاستروجينز والادراجز والفارماسيوتيكالز كلها قاعد تدخل وما نعرف الفيت وين ار ذي جو. فاحنا محتاجين نعرف مسارها من البدايه الى النهايه، الى هل تدخل في النبات، هل تدخل في الاوزان، هذا الشيء. وفي تجارب في كثير من الدراسات في الستيتس على الهرمونات اللي تنتقل عن طريق الحيوانات الى الانسان، وهذه يجب ان نخلي بالنا منها. فضروري نكثف البحوث حول امكانيه هذه المواد الناشئه، المخاطر الناشئه. هناك ايضا توصيه ضروريه جدا على اجراء دراسات على تاثير مياه الصرف الصحي، استخدام مياه الصرف الصحي على المدى الطويل. لا ننظر فقط الى الاني، انما ننظر الى المدى الطويل. لماذا المدى الطويل؟ لان هناك في بعض العناصر تتراكم مع الوقت، يعني مثل ما ذكر ان هناك في المعادن الثقيله في البي اتش التربه اذا كان كالكيريوس بي اتش اكثر من 8 راح يصير لها immobilization ممكن يصير سمي مع الوقت، وهذا ما جرى. التراكم يجب ان ننظر له بعين الاعتبار، ومش فقط ان احنا الان ما في عندنا شيء، يجب ان ننظر الى المياه الجوفيه. اجين التركيز كان كله على الاستثمار في مشاريع حصاد وخزن المياه والامطار والسيول وعلى التغذيه الصناعيه. هذا يمكن اكثر شيء اخذ الاهتمام في هذا المؤتمر. واضح ان احنا السيول عندنا تزيد، واضح ان عندنا المياه الصرف الصحي قاعد تزيد، فالتغذيه الصناعيه هي المجال الامثل. ويجب النظر يعني تعتبر هي هذه. طبعا التغذيه الصناعيه المياه الجوفيه احنا عارفين ليش المخزون يرتفع، مرتفعات غاز مياه البحر، كل الامور دي احنا نعرفها، بس هو في تركيز على التغذيه الصناعيه واستثمار المياه الصحيه. المياه البلديه حقيقه لم ينتج منها العديد من الاشياء، وانا يعني استغربت من المياه البلديه كانت عندنا للاسف الاوراق اللي قدمت عليها ضعيفه شوي، يعني قصدي مش قليله جدا. وكنت اتوقع اكثر. المياه البلديه هي الان المستهلك الاكبر في 3 دول في الخليج، الكويت وقطر والبحرين. المياه البلديه هي اكثر من 50% من استهلاك الماء، القطاع الزراعي ان شاء الله ان شاء الله. فان شاء الله تجينا توصيات من المؤلفين بعد بشكل شويه اكثر يعني في النهايه، لكن احنا عندنا بعض التوصيات اللي احنا استخدام طبعا الادوات الاقتصاديه في القطاع البلدي لتقليل معدلات استهلاك الفرد، وتداخلت هذه الجلسه المياه البلديه مع الجلسه الاولى اللي هي اقتصاديات الحسنه. بعض التوصيات اوريدي موجوده فوق، فراح نحاول نحطها. المياه الصناعيه تم النظر لها من وجهتين نظر. وجهه نظر ان هي كيف يمكن استخدام المياه الصناعيه، اوكي، ووجهه نظر اخرى كيف ممكن ان نمنع المياه الصناعيه من تلويث المياه الطبيعيه. كذا في عندنا تو سايد للكوين، فيجب النظر لها بشكل. اخر جلسه هي كانت جلسه الهايدرو انفورماتكس. بصراحه يعني هي تعتبر كروس كاتنج، من غير في كانت ميجرت، في كانت مانجرت، وهذا ما جرى الكلام من كذا. لكن طرحت بعض الافكار اللي هو السنترلايزد داتا والموديلنج، ربط الموديلنج بالداتا، والسمارت ميترنج، اوكي، والسمارت irrigation سيستمز. كلها امور الان العالم ماشي فيها بشكل كبير، وعلينا احنا ان ايضا نتماشى معها، لان هي بالفعل يعني مؤثره في اداره الموارد المائيه. واعتقد انه راح ننزل بعض التوصيات القويه في هذا الشيء، وهي اول مره تنزل كسيشن لوحدها، كسيشن. عاده احنا نوزعها على في الووتر، في الجراوند ووتر نحط الهايدرو فورمال. هالمره احنا سوينا هذا وان شاء الله نبني. في النهايه هي ادوات للمسانده في اتخاذ القرار. هذا هي الاساس، ويجب ان تكون جاهزه لي انا لما اكون باخذ قرار، مو انتظر شهر شهرين لغايه ما حصل الداتا، لكن لازم يكون عندي انا بريس اوف باترن تطلع عندي الداتا واقدر اخذ قرار. هذا ما لدي سعادة الرئيس والمجلد.
شكرا يا دكتور وليد. طبعا في ختام هذا المؤتمر اود ان اتقدم بالشكر الجزيل طبعا لوزاره البيئه والمياه والزراعه والجهات التابعه لها، خاصه المؤسسه العامه لتحقيق المياه المالحه، شركه المياه الوطنيه، الشركه السعوديه لشبكات المياه، والمؤسسه العامه للري لدعمهم لجهودنا ودعمهم للجمعيه من بدايه المؤتمر. كذلك اود ان اشكر الزملاء الحاضرين والامانه العامه. هي ذكرتني، شكرا. هذا اهم شيء، الامانه العامه موجوده ويذكرنا جزاهم الله خير. الامانه العامه لمجلس التعاون داعم رئيسي ومتواصل للجمعيه. فمعليش الوقت منتهي وتعبانين من قبل. المهم انه احنا نشكر اول شيء اللي اهم يعني او في ختام الموضوع. اول شيء احنا سعدنا كثيرا بوجودكم بيننا ومشاركتكم في هذه الظروف الصعبه، لكن اتمنى من الله سبحانه وتعالى ان يجمعنا في فرص قادمه باذن الله، وخاصه انه ان شاء الله الجمعيه بعد سنتين سيكون عندها المؤتمر الخليجي ال15 للمياه، واللي ما ندري حيكون في احدى دول المجلس اكيد، لكن ما ندري وين. وان شاء الله بتسمعون اكيد عن وقته. في الختام اود ان اشكر مره اخرى جميع اخواني وزملائي اللي شاركوا اول شيء في الاعداد لهذا المؤتمر، سواء اللي راجعوا الاوراق العلميه، اللي حكموها وكذا، وكذلك بالحضور والمشاركه. وبذلك نختم هذا المؤتمر باذن الله. السلام عليكم ورحمه الله وبركاته.
الغداء. تعال لحظة في صورة جماعية. في صورة جماعية برا.
الله يخليك.